All right. Hello, everyone. Welcome to my stream today. Sorry, I'm running a little late. I'm not used to streaming so early. I had to actually rush to get everything done in time before I started. But come say hi in the chat if you're here. All right. Yeah. Hey, how's it going? Yeah, no. Hi in the chat if you're here. Yeah, okay. Clever. Yeah. Today, we're going to be looking at some like design level like topics. Some people commented they really liked like those deep dives I do later in the stream. To be fair, I know they're not as interesting for everyone, but I feel like sometimes this gives a little insight into what my work looks like, which I don't know. It's helpful for me, just to kind of like work through these things and kind of explain reasoning. And it's different content, like some people come on stream and they'll be like live coding some kind of project that that they've been working on for months, and they do that. I don't really live code that much unless I'm like doing a very specific demo that I'm trying to show off, or I'm like trying to teach something. So like for me, most of my time is spent actually working through the design aspects of problems, right? Which is a funny thing because it means that it's funny, I have This Week in JavaScript where, I talk about what's been going on and all that. And I find myself farther and farther away from it, especially as the conversation has been gearing towards stuff like AI, because like, like it's really funny watching all these like vibe or seeing all these like vibe coding, you know, comments and people talking about all this perspective. And I mentioned this a couple weeks ago. Just like what I do is the opposite of vibe coding. If I get to the code, hopefully I've already figured everything out. Um, so it's very different kind of zone. As I said, I find I've been finding the last while, especially being very disconnected from like this week for most things, because the topics of interest right now are just so far from anything that I find interesting or important. Dan Aber, Dan Abramoff posted another post today. Yeah, I might have tracked that down. He's been posting weekly now for like the last month, which is interesting. I have to admit, I think I know what he's doing, right? What Dan's doing is he's trying to find the right framing that resonates, and I think he's realized that not everyone a single framing for RFCs work for everyone. So he's like, what if I approach RFCs as HTML or as functional programming or as two servers? He's trying to come up with like different ways to like say the same thing. Of course, for me reading these posts, um, especially after the really long one, the first one I did, I've just like it's just been like it's like reading the same article 4 times in a row. I think different people get different things from them though, because I think this is like certain gap. He's gonna write 10 versions of why RC post works until it works. Is good until it works. Yeah, something like that. I mean, sometimes that's what it takes, right? You write the same thing enough, you come at it a slightly different angle, and suddenly it like clicks for people. Um, we'll talk about RCs maybe a bit later. That's at least a topic I can talk about. I have some thoughts and notes because I actually got in first time in a long time of a little bit of it wasn't a discussion. He didn't really respond to me, but some comments in RFCs with Dan on Blue Sky for the first time in like almost over a year. So can kind of talk about where perspective where RFCs sit now and stuff. Yeah, no, I mean, freaking hell. I mean, if you really want to talk about like, yeah, I mean, this is always the problem with this stuff, right? Like, there's the actual, like, there's like the truth of the matter from like how things should be, and then there's like the reality of the matter. And I mean, if you want to talk about like just like not caring at all, I mean that's a perfect back and forth thread, and it blew up. I guess we get Uncle Bob's. What is he wearing? Like a one of those like towel bathrobe things. I don't know. Just when that's the interesting point of discussion and not the things that we can be creating. It feels very distractionary, very almost like 1984. I mean, but content creation needs to come from somewhere, right? So, I mean, I was thinking about this. I mean, sorry, this has nothing to do with like the general like topic stuff today, but like obviously most content creation is reactionary, right? And it's because a lot of the value people find in content is that like there's a lot of information sources out there, too many for people to actually discern themselves. So we get to this like point where we are depending on others to kind of filter down that information for us. And the power of good content creators is that they can like you know make the takes that are either interesting or best represent like what your take should be. They can make the critical decisions for you essentially, and then you can just like repeat it, and this helps you not have to discern the wide amount of information out there. I don't know if that's a pessimistic view of things, but like it has value. um but like at a certain point it's the same echo chamber regurgitated conversations over and over and over and over and over again, and you just keep on going like, why can't people be excited about something new or something different? And I mean, you can kind of get why though if you think about it from that perspective. It's like if people are generally looking for how to like discern all the information to a single opinion, then um why would they want different like information out? Like they're trying to get rid of the information overload. Why would they want more information? So it's like, I don't know, that and AI together, just they're a wonderful pair of like mediocrity. I don't know else how to say it. Yeah, this is a green screen. Green screen in my own office. Just like I can't sit this angle, otherwise I'd be facing the door. Yeah. Sequel is bad. Gets into a bathroom. Yeah, I mean, whatever keeps everyone entertained, right? Um, Prime reacts to Theo reacts to Rich Harris. I wish it was reacts to Rich Harris. At least, uh, if this was real, I might even watch this. Right? The problem is it's not even. I don't. It's not even Rich Harris at the end of the line. I mean, he might be hidden like 4 more layers down. I don't know. It's interesting. Is it just a lack of new content? I watched a video the other day from Theo, and he was reviewing. He's now reviewing like like original um, React talks from like 2013, which are great talks. To be fair, I would review those on my channel. I think I might have actually reviewed one of Pete Hunt's talks a while ago. It was really interesting. He spoke for a bunch of students at college. I can't remember if I did that on screen. And my favorite, the thing I want to point out is how whatever, cyclic, whatever these patterns are, because he goes on a big thing about why like what he called KBO, or like basically data binding and like smart data flows are bad. Like he's very functional programming oriented. Pete Hunt was, and immediate programming, like why in game engines, like you could tell he has a graphics. He probably has some kind of graphics background too, not just functional. Like you could tell that like basically things where the data is special was not where React wanted to be from design, and why it was so elegant. Yet when you take his talk and you think of React in a post hooks world, it's like every single criticism he had of the other solutions that weren't React, you could now point directly at React. So like there's a reason why these elements exist, right? The reason React went to hooks in the first place was because of certain compositional aspects, because you know they needed rules around execution and lifecycle data. You couldn't just naively re-render everything, because if you naively re-render everything, it's really inefficient. It's the same reason why under the hood in some, the new stuff with graphics like Vulkan and stuff, there is some retained mode stuff going on here. If you just immediate mode, you can't, like, immediate mode or like re-render everything will always be less efficient, right? So like the actual battle isn't whether like these like at a purity sense these things are actually better, like, because they need aspects of the other. Like, it is true that when you keep state around, it gets complicated and it gets messy, but it's also true that when you blow everything away, that it's not efficient. So like it's a question of whether you can provide the developer a certain mental model that lets them think one way and have it like be optimal where it needs to be. And that's been the whole debate, versus being like, you get it, what you see is what you get. So I don't know. This is, I'm just kind of rambling right now while waiting for people to join up on the stream, but it is kind of a interesting to kind of see how much like 10 years puts on certain perspectives, and how nothing is as pure as we'd like to think in our ivory towers of design. But it's something we have to consider from a design perspective. And that's really what I'm aiming at when I'm looking at here today. Like, I want to look at design issues, because that's what I do in my work. I don't vibe code. I look at what other people do, but I don't often react, like, or react to the react. Like, we're in a zone here where we want to hopefully create new novel approaches to problems, so that we can further or better what we're capable of, not just there's important parts of the cycle. Sometimes the goal is to make something easier that's been done before, but at a certain point you have to also do what's not done before. So that's why I'm here. That's why we're doing the stream. That's why I like looking at these problems and kind of thinking about it. Why I have incredible respect for the other people working in this realm of trying to think out new problems. That's what and solutions in these spaces. For everyone from Rich Harrison's latest async proposal, we might take a look at that, to a lot of the work that the React core team has been doing. Right, it's easy to get caught up on like in this space, like how to get caught up on like how things could work in this like perfect world, but there's a certain rubber meets the street thing going on, and that reality has to always be part of our consideration when working design. All right. Okay. Yeah, no, I'm streaming early today. Do you know the reason that I'm streaming early today? And it's going to be probably this way moving forward, is that recently, I think I mentioned, had a baby, and I'm actually doing school drop off and school pickup. So I actually have to sandwich my streams in between that now, instead of being able to just take the whole afternoon. So we're moving earlier, and maybe even a tiny bit shorter, but that will not get in the way of us being able to cover some incredible content. And as I said, very excited to have you all here in the chat. We can talk about these topics and kind of look at what goes into these designs, and even provide some feedback. Let me see here. I'm actually opening up Twitch now, because I haven't got that up yet. Yeah, we got some people in there. There we go. All right, there we go. Thank you. All right. Yeah, I mean, it's awesome. Sometimes a bit tiring, but definitely awesome. Okay, so we should probably get started with some actual topic for today, because have notes to work with because I had that I took that time off. Um, so I have to actually sign into HackMD. It's been so long. Um, I actually what was I going to say? I actually had a bunch of notes sitting on reserve. I didn't even. I looked at them last week while we were going, or 2 weeks ago when we were doing the stream, and I actually was like, nope, don't have time for this. But I actually have like several of my written notes on the topic today. And the topic today I'm looking at is SSR, primarily looking at reactivity and async in SSR. And I think a bit of this might help to start with understanding how SSR works in most solutions. Um, I know we've covered this in the past, but I mean, let's get into the fundamentals. People can ask questions, and then we can kind of go from there, right? Let's see here. Share my screen. Oh, and this is one of those things that I don't think people realize about some of the solutions, like because you can get really far without certain niceties or tools. At one point in that post, Rich actually lists off a whole bunch of features that he's very excited this unlocks. I'm like, crap, Solid's had all of those features for 6 or 7 years now. Like, oh, not from what like right after 1.0, but actually before 1.0. Actually, there were things that I wanted to get in for 1.0, and I started remember thinking like Solid was surprisingly full featured. People can talk about the ecosystem and people can talk about like, oh, there's not enough libraries and support and all this stuff. But it's like, what can you do as a developer? Like all I could do was basically give people every capability that they could want, and hope that they build with it, right? I can't build 5 different ShadCN component libraries, but what I can do is give you streaming, async SSR, automatic serialization, you know, like transitions, you know, like so like I don't know. It's interesting when I mean I don't. Sometimes the argument can be like maybe you don't need all these things and they're just kind of nice on and like there's other things that should get priority, right? But it's like it's a tricky kind of balance, right? Because it's like you build the thing, you hope that people, like yourself, generally, it's always a little self-reflection, will like, because you kind of imbue your own personal perspective on, how to solve the problem when you build a framework or tool like that. And it's like, it's it's interesting when you basically build all this stuff and then like people are like, oh, it's not necessary, or we don't need this, and then like 5, 6, 7 years later they're like, yeah, this was always the way to do it, and you're like, okay. you know I think I have a Dan Abramoff post about that in concurrency, and I released an article this week actually about how I've been working on Solid for almost 10 years. In a few months it will be, but this will be my 10th year of working on Solid JS. But the truth of the matter is your average end consuming developer is not going to notice this stuff. So like, it's not a bad bet to not build out some of the features and stuff. Like, I mean, I think I might have said this before, like from that kind of depth of perspective, like I think things like Quick are incredibly ahead of their time, in terms of capability, things like the resumability. I think these are topics that people will in, 5 years ish, 5, 6 years will be like, oh yeah, this is something that's important. But right now everyone's like, yeah, what's that crazy Quick thing in the dollar sense? Like, they find reasons to pick at it based on stuff, and part of it is legit. Ergonomics are fashion, right? Like, you there's things that are deemed acceptable that weren't acceptable before. So like, signals are a perfect example. In early 2010s, a lot of people didn't think something like signals were acceptable. They were too magical. People weren't used to paradigms like this. It was too big of a shift from where they're going. But after 10 years of React, it's like, thank God there's a different option, right? But it did take those 10 years. So there is that aspect of it. But on the other hand, I mean, maybe we shouldn't be so focused on fashion. Like maybe we should look at the capabilities. These are interesting things. Like don't get me wrong, from a design perspective, when you're building a tool, it's always a marriage of both aspects. You need to be aware of what's usable, understandable, accessible to your end user, and versus like the raw capabilities. Otherwise, like vanilla JS is the fastest or the best or the most efficient or whatever. Like it always is. But um, it's unwieldy to build certain things just purely that way. You build abstractions. You do this. So like you have to understand that like the job is, in a sense, finding good developer experience for solving hard problems, right? Your goal is to let people get to a place where they can do something that seems relatively simple for them, and then get results for something that is, much trickier to accomplish. So one, it's like two sides of the same coin. One can't be approached without the other. So it's not like these live in space. So, when things are ahead of their time, they are legitimately ahead of their time. But I think they should still get our respect and understanding. Um, as I said, I think Quick, for example, and its resumability is one of the least respected future technologies that's incredibly relevant, right? In a sense, like when I look at the scheme of things, React server components are just a reimagining of what Marco did, 10 years ago, right? They're a better version, right? Marco didn't get everything right, but that's like the push on that. When I think of what Quick's doing, it's probably going to be a worse version of what we're doing in 5 years. But I think it is something that you know people should like at least understand that this is a thing. It's not just like, oh, you're not going to need it. Go find, what was it, Michael Jackson or Ryan Florence? They had a Twitter post in 2016 being like, oh, no, it wasn't Ryan Florence. Ryan Florence was always in, but Michael Jackson is like, oh, server side rendering, not going to need it. And it's like, technically, yes, but like 4 years later, you're building a server rendering framework, right? Like, um, we have to be careful with absolutes, especially when it comes to the advancing of technology and fashion. So, like, web components are ahead of their time. Yeah, that's an interesting one, right? For me, I feel like web components were behind their time. Like it's the other thing. I think web components are exactly what I would have wanted back in 1997, or maybe by 2000, no, 2003, 2004. That's when I would say that I realized. And then it took 6 or 7 years for them to kind of get there. And then and people like, okay, we should make a proposal for this, and then they finally do it. And then like 20 years later, you're ending up with like, it's like when you end up with how I said that like RSCs are maybe a slightly better reimagining what like Marco did 10 years ago. Web components are like, what if you just got what Marco did 10 years later, you know, and actually maybe a little bit more compromised because you had the appeal to like the lowest common denominator. Yeah, I think that's how I'd take it. Um, but that being said, technology that's like old comes back again because like usually when we cycle along these things, it's not just because like we do the spiral staircase up. It's because like if you go really far one direction, you start realizing that you lack something else, which causes you to swing back the other way, maybe too far. And like a perfect example, as I said, is remixes got that feel for me, right? You kind of get back to that like PHP days of things, right? When I mean, I think the real answer is slightly more granular, kind of like TanStack, but sometimes it takes swinging past the mark to get to where you need to go, right? And in a sense, I think this is like web components can give us that sort of like where to swing back to when we're like, look, stuff is too complicated. There's too much going on here. We need to somehow figure out how to make this base level. As I said, the only problem with web components isn't what they in a lot of ways what they accomplish to do. It's the fact that they're too ambitious, like, and then they encompass too many things. If you kept the pieces small enough and fundamental enough to the service building blocks, and then the parts that didn't fit could always be not used or swapped out as needed. The problem is because it's too all encompassing that it's web components. I know it's 4 different specs or whatever, but because it's web components, that's the problem. If you're like, okay, I like custom elements, but the shadow DOM's no good. But even the shadow DOM's too big. Basically, like the problem there is like you built a framework for the platform, and then there's 14 other, the KCD people who think they have a better version of building a framework that doesn't work that way. And the thing is, they're not wrong. So it's like, fight. Like there isn't much option there. Instead of coming up with something that was actually fundamental that everyone could actually leverage, we now have just another standard in the standards pile. So it's like, yeah. Anyways, we don't need to talk about web components much more. They're not really worth our time. Okay, let's continue on, because I've already been going for 30 minutes and we haven't really even touched into the topics today. So yeah, should we just jump right into, let's see, I've got my scala draw here and I'm zoomed way the hell out. Right. Yeah. See if we can find some space on this chart somewhere to kind of do. I haven't actually decided what I want to draw yet, to be fair. I'm just trying to think of, like, generally, what do you all know about SSR? SSR is actually very, very simple process, and it's important. We could differentiate it from like traditional server rendering, but there's too many similarities at the beginning standpoint that you're not even going to really make that much of a difference. The biggest difference between SSR and other server rendering stuff is the templates generally aren't designed to only work on the server. That's generally how you can differentiate it. When we say server-side rendering, we're like saying like we're taking something that maybe isn't primarily server-side and making it server-side rendering. That's why we're denoting it. Otherwise, you'd just be like, I'm just rendering some some HTML. Like, why is it server? So why is there that acronym? Draw a black background, draw a rabbit. No. I'm back to white backgrounds. Black was fine, but I'm back to white. Sorry guys, I know it's bright. Yeah, Elm did do that at one point, and I think for Elm's functional model, it's much purer. But Elm's also very academic in that sense. I think that, that's it. I think that this is one of the challenges about where the rubber meets the pavement, so to speak. So, okay. All SSR is, for definition today, is we're going to take some kind of potentially client side templating, and we're going to render it as well on the server. That's the baseline of SSR, right? And by rendering it on the server, all I mean is generate strings. So you have something like JSX or Svelte template or whatever, and you're going to generate strings, right? CSR pre-render, sure, is the thing, right? Pre-render is always a funny term because you're like, do you mean at build time? Do you mean at runtime? See, it's not that big of a difference. But like generally units strings, and I mean I can just let me grab a solid playground here for a moment, and I don't even know what this example is showing me, but if I look at the output here, see, this is the JSX output, but if I switch to server-side rendering output, and this one's too interactive. Let me do something that's simpler. What you're going to see is, yeah, it's not even the point. Solid's implementation, this is like almost like a tag template literal. It's literally taking an array of strings here for the button. So the button, this attribute, and the button, and then basically there's a hole here and there's a hole here, and then we fill that hole in this case with a hydration key, which we'll talk about later, and then the escape text of the child. So essentially, what this function does is it does a little bit of processing, but for the most part, it just adds strings together, right? And if you go to svelte.dev, hopefully they still have it up here. Where's the playground? What do they call it? What do they call their playground? The REPL? Is it still playground? Okay, they call it playground. Sweet. Hopefully we can see. I know they've updated theirs now to use like stacklets, but if I go in here and I see again, client side, you have like some DOM manipulation. But if you go server, yeah, they're just adding, literally, you can see the adding here. They're like, here, add this string over. See, they can tell this is static. And in fact, Solid could tell that this is static as well. So I need something that can update. So let's say on click name plus equals exclamation mark. Okay, guess what? Now we're back to the example I was showing with Solid, where you have the string, and then you have the escape. See, told you there's always the escape, and then the string again. Again, we have an SSR function. The reason for that is to handle nested recursion. I'm not sure Svelte has to worry about nested recursion examples, but essentially it's the same idea. You're just jamming a string. If I go to view, you're going to see, I believe now, string as well. Classically, view was not like that though, and nor was React, nor is Preact, whatever. Because the way React works is things like Svelte and Solid, which use a compiler for their templating. To be fair, React uses a compiler too, but there's a difference when you have a compiler that has options like this, like, oh, we're doing client, we're doing server, and a framework where like they're like, we always generate basically the same JSX. And the React, has one JSX transform, and you just happen to run that JSX in different environments, which is kind of a cool thing, right? Because conceptually, you're like, okay, like this part of the step isn't platform specific, right? Classically, because Svelte's compiler basically compiled in, and this is not true of Svelte 5, but if you look at older Svelte, like basically compiled in like the DOM operations like straight in as part of the compilation. It made it difficult for them to do like universal rendering, right? What they would do is Rich wrote a separate like Svelte GL thing, right? Where Solid used its reactivity system as kind of a replacement for the hierarchy of the virtual DOM. Like there is actually decoupling between the reactivity and the DOM specific operations. And Svelte 5 is like that as well. I remember someone coming in our chat working on the Svelte team was saying that I'm working on a universal renderer. It was for Svelte 5 and is very inspired by the Solid one. But my point is, having some capability, like in the Solid playground here, we actually have this, you can say client side with hydration, and you have slightly different compilation here again. It gives you this ability to kind of tailor for the environments a bit, right? And there's no DOM on the server. The reason the server has a separate compilation is because it's more optimal, right? The fact that there's no DOM on a server is actually, a pretty big deal. I mean, you could bring in the DOM, but that is kind of slow. Why do you need that representation? Even the React's virtual DOM approach is pretty slow because you actually have to build the virtual DOM and then go, okay, now that I've built this, run through this object and turn it into strings. It's much faster to basically just be like, I'm just going to append strings as I'm doing it, right? I'm just going to add these strings together. Let's see if, where was I? Output, server-side rendering, like, let's just smash these strings together. Button, hydration key, type button, escape, right? But this is a simplistic look at the systems, right? This text is too small in the Svelte playground. Yeah, it's because I don't hang out there as much, so I don't have it set up. Thank you. But yeah, I was just showing it's very much the same sort of approach. Yeah, exactly. And it's interesting. I'm sure Hono's server side rendering of JSX is similar. The funny thing is, this is a great way to approach it on the server. This is a terrible way to approach it on the client, which is why a lot of these solutions that are like built this way for server rendering JSX are actually kind of terrible for their client side implementation. Like when they're like isomorphic, like I don't know if anyone finished making Hono's JS framework benchmark, but it was definitely competing with like Blazor and Alpine. So okay, this is great. End of story, right? We're done. Um, well, there's this thing called async, which is kind of a pain. And the reason async is a pain is you can't just make everything a single string. Well, you can if you fetch everything ahead of time, right? See, React, even with its virtual DOM and everything, still had render to string, and we all have like server side rendering. We have this ability to say, give me the string synchronously. How do you solve the problem if you have something async? And for the longest time, the answer was prefetch. But I mean, that's tricky. What if you're fetching deep in the components? How do you know what the prefetch? Well, get server side props or whatever. Like you could make hooks in to a build system compiler and basically like hoist out um, the data fetching, and then it could know it, right? And then you can basically do that ahead of time. And same principle with Remix when it came out, because you have to remember Remix was created before React actually released Suspense in a like for data fetching, and that they actually Remix team actually ended up like creating their own mechanisms that are like Suspense. They created their own streaming mechanism. They basically had to do everything themselves because React wasn't ready with a solution at the time. Um, but what I'm getting at is that's a solution. You can kind of pull all the data fetching ahead of time, and then kind of just render it. But that doesn't help with streaming. To be fair, that just means that's your classic SSR where you do all the data fetching and then you send everything when you're done. Which means that your request responds at the speed of your slowest data coming back. Which is why people used to say stuff like get server-side props is cursed or something, right? And a lot of Next.js apps actually ended up just doing fetching in the component anyways. So they were only like half leveraging server-side rendering because I mean they kind of understood that like if the page has to wait for your slowest data request to finish to show anything, it's kind of awkward. So a lot of them would like maybe like do some basic stuff and then basically fetch everything in the client. And that was actually kind of the state of SSR in 2018, 2019, which is kind of funny because I didn't think that I would have assumed most people were going to do like the data fetching using like its server side props. But I think we'd already kind of done full circle because I was looking at all those demos, like real world app. You guys remember the real world demo? It was like a medium clone that you could do in every framework. This used to be like the demo to make, when people are like, I want to show that my new JavaScript framework, is capable. This used to be this was the demo because you could basically show that you could do auth, you could do data fetching, you could do rendering, pagination, basically every feature that you need in a framework, you could basically do through this demo. But it kind of fell off popularity. But when I first came into this, I was doing client side, and most people wanted to do like full stack. This is where you could show up your Sapper or your Nuxt or whatever. And I was destroying them on page load because they were all doing that wait for the string technique. And I think real world people realized, okay, yeah, I'm just going to fetch in my next components and not use get server side props. But which is so much so that when Remix came out with their loaders, people didn't instantly go, oh, this is the same thing. I mean, they should have, but they didn't. They're like, oh, this is novel, just because people had gone so far away from it in Next by the time that came out. Anyway, okay, so that kind of sucks. So let's talk a bit about how can we solve async so this isn't the case. And one of the ways is make async discoverable. And by that, I mean, like, as part of the rendering process, instead of saying like, let's do everything ahead, you can basically go like, as we're rendering, we're going to find what's async and then do something like a boundary of some type. Like this is the suspense boundary. Marco again, what's it called? Async fragments. Just giving them a quick shout out. It's worth doing. But they described how they came up with a streaming solution, which is basically a discover as you render solution. This is like Suspense back in 2014. But if you look at this, they have this async fragment data provider. So it's not as nice as API, but essentially they broke their HTML into bound sections and said, look, as stuff finishes, you can send it to the client, and then we can just swap these in later. And I've done whole streams on streaming, but the gist of it is you can just keep on appending HTML to the end of the document, even after it's been closed. And HTML it's very self-correcting. You can stream stuff even in order without closing the document, and the browser will somehow figure out how to render it to the best of its ability, because like closing tags are kind of optional, right? So like this is really the approach. I mean, another option is, I think Svelte had an await tag. Again, they didn't really do it the same way. But the idea with the await tag was you could like, because I think originally the await tag only actually properly worked in the client, even though you could see how it's a similar mechanism. The biggest difference between the await tag and suspense is the await tag requires that you pass the async, like the promise, to the block. I'm trying to remember if Quick's approach is like this too. I think it might be. They have like a resource tag. But basically, you get to the block and you say, wait this block on this promise, right? And you can kind of see this like as a fairly decent approach to doing this, because you can just be like, okay, I can render part of my page, not wait on the slowest thing, and then when I hit a promise, block it out, right? Web components spotted. Web component function, web component syntax, but not actual web components. Marco uses tags as their code. So this so what Marco tends to do is actually, actually, to be fair, this is the output. You don't actually write async fragment. Marco could kind of do this automatically later on. Anyway, but yes, using it's because it uses tags. It's not actual custom elements, but it uses the syntax, because you can. I don't know, a lot of people know this. The biggest thing custom elements add is lifecycle to tags, but you can always just like make your own tag up. A lot of times we use dashes for the same reason custom elements uses dashes, for the reason of not conflicting with the existing thing. Like if you have a dash in your name, you know that you won't ever have a like namespace conflict with native elements, because native elements cannot have a dash in it. Anyway, what React ended up doing with suspense, which was interesting, was instead of just putting the promise at the boundary, because the challenge with putting the promise and the wait tag is that if requirements change down here, you have to go and start adding things to this async, or add your own, maybe you should add your own nested async fragment, but everything has to be kind of hoisted up to where that fragment is. And what suspense is, for example, is an inversion of control. It's like saying like, hey, child, try to render, and whatever you can do, it's fine. But if you can't finish, I got you, right? It catches any of this stuff that can't be rendered and says, I'm going to show a fallback instead, and you take as much time as you need, right? And what this does is this inversion of control meant that you don't have to know it above. You could localize kind of data fetching, or not data fetching, but async requirements. There's a difference between data fetching and async requirements. You can imagine there's still benefits to fetching earlier, i.e. higher up, because if you nest things inside, you could picture that, like if something blocks something that blocks something, you get waterfalls, right? So there's a difference between being the question of like, can I render this currently, and fetching down there. But what I'm getting at is, this is the kind of approach we took to SSR. Generally speaking, we recognize that there's bounds inside parts of the HTML requirements. So, but what do you do within those bounds, right? Because the tricky part is when the await's on the outside, when it's like literally like the await tag, then you can just get there and go stop, you know, and then you go continue. But when it's discoverable inside and you have to bail out, then you end up in this kind of interesting zone where um you more or less maybe have to re-render stuff. In the case of React, it tries to render, and then when it fails up to the boundary. It's like an error boundary. Suspense is very similar to an error boundary. And then when it finishes, it tries to re-render it again, right? That was the classic model for how React handles the server, which can be kind of inefficient. To be fair, and the reason I'm bringing this up is that's how Solid works today as well. Solid has this like crazy, beautiful run once, retained mode, ultra performant approach in the client. But then when it hits a suspense boundary on the client on the server, it's just like, oh well, let's try again. Because it was simple. When I was benchmarking Solid's SSR rendering, it was like several times faster than most other solutions. So I was like, oh, what's the cost of just doing the server rendering again for these fragments or suspense boundaries? Because if you're already like, you could do it 3-4 more times, whatever. If you're already 10 times faster, like who cares, right? But maybe that's an unfortunate side effect of this whole thing. But it's the key part is once you go down this road, smash to string doesn't it becomes tricky because you either, as I said, if you smash the string like this, you have to re-render it again because you can't go, oh, this name is async, like continue where you left off. You're just like, okay, go to the boundary and smash to string again. That is kind of the problem, and that's exactly, as I said, what Solid does, right? We keep while we're server rendering. Well, actually, yeah. Now I'm getting to the heart of the matter. If you fetch below a suspense boundary or below like an async fragment here, and people are familiar with this with client-side React as well. If you're fetching below and it's re-rendering it, it's gonna the most naive thing it's gonna do is fetch again every time you hit the component again. First time, like from its perspective, like this wasn't here before, it failed, it errored, it doesn't know the state inside this boundary, it's garbage. So it goes, runs, fetches, renders some stuff, sees that it's not ready, bails out, collects the promise, finishes, runs again, hits the fetch again, and then fetches again, fails. Like, how does the old promise from the last run get into the new promise in the new run if you're just re-rendering it again, right? And the truth of the matter is stuff like use memo and React, like hooks, don't actually protect you in this case. This is why people have had such a hard time implementing suspense. And there's that whole like fetch up, hoist up your fetching thing. Like, how do you establish that these are the same thing? And there are solutions. The reason that like memos don't work in React that way is actually a slightly different thing. You could pretend or conceptualize that they could work in React, that you could like keep the reference. But like in a system like Solid, which doesn't have that kind of reference stuff, how did I solve this? Well, hierarchical IDs, right? And the funny thing is, I found out React does something similar themselves. If you actually, how does use ID work? I Googled this a while ago and I came across, what is this? How does use ID work internally in React? Right? You have to remember use ID or create unique ID in Solid gives you an ID that's the same on clients and server rendering. Right? And they go into this, but they talk about the fact that they use the fibers inside. They're actually looking at the VDOM tree, and they're like get tree ID identifier prefix blah blah blah. Like they're building up basically this code based on its parent, because if you have a tree of structures and the tree can change shape or things can be added and removed, it's possible that things get created in different order, especially with async. It's possible that like one thing resolves first this time and something else resolves first another time. But as long as the decision of whether to show it is above that resolution point, then that's fixed. So essentially, you can use the hierarchy of the virtual DOM, for example, to be able to come up with stable IDs. And this goes through this whole thing explaining how um, like the fibers basically end up being able to generate um, this hierarchical ID. And to be fair, I wasn't aware of this. Honestly, this hadn't come out like as a public API at the time I was working on Solid Solution, but Solid's hydration key is almost identical to this because the idea is, look, if you have data fetching, you could set a key yourself, but if you want the system to, like if you just go, hey, I want to fetch this data, like in a component below some suspense, and you want it to just work and it's doing a rerun model, well, you need to be able to find it again when it runs again. And so I basically came up with an ID scheme like this, which essentially would match up. So when it reran the tree, it would be able to find the resource again and go, okay, I've got the promise, I can continue. Right. As I said, it's funny. I released the solid version before React released this, but if you go back to earlier versions of React, internally, React had hydration IDs on their DOM nodes for SSR back in like the 0.14 days or whatever, like way back in the day. They changed their hydration approach to be better around React 15, I think. But they've always had this ID system on virtual nodes. They just didn't expose it to you until after. Like, see, look at this. You can see it here. Z0 1 0 1 1 1. Anyone who used Solid should know like this looks very, very similar to our hydration keys because you essentially have to mirror the tree. In their case, it's the VDOM node tree. In Solid's case, I used components because I didn't really care about this individual elements. I need it for context. So essentially I used components. But there's other, like, you're dealing with a hierarchical graph. So it's just something to consider. So this is my kind of preamble. So you start understanding the problem space when you're doing re-rendering, when you're doing async operations. It's not enough, and this is why it's taken a long time, and why you need these foundations for this stuff. This is why Svelte hasn't done this in the past 6 or 7 years, or I guess Svelte's turning 9 pretty soon here. I mean, it's possible because I mean, okay, old React they create their elements one at a time, and because it's JSX, they could be created in any order anyway. So like Solid clones templates, so we actually only need we actually generate IDs per block of code, where React creates their elements one at a time. So I feel like this is like a historical thing in terms of like they basically every element could be matched up one for one, right? Um, they don't need to output this anymore because when you have hierarchical IDs, I think they realized at a certain point that if they changed their state management of it or did a few things, it's basically predictably consistent. So like it will render the same on the client or on the server, which means without rendering the IDs into the page, you should get the same output on both environments, which means they should just match. I mean, this is the source hydration mismatch, right? But conceptually, like if you're if you basically have the right kind of state mechanism and you have this hierarchical system that keeps uniqueness this way, you should be able to match as long as things render the same way on both sides. Couldn't a lot of these complexities be avoided creating things weren't primitives but components? Well, it depends. If you want to say it is the suspense boundary, then you don't need it, but then you don't have inversion of control, which doesn't scale, right? Like if you want to say it's an await component, for sure. Otherwise, the fact that it's a component or not, like whether I'm making the ID because it's a primitive or it's a component. As I mentioned with Solid, we use components for doing this. Doesn't matter. I still need this hierarchical ID system that in theory I wouldn't need otherwise. With Svelte 5, we gracefully support mismatches in SSR and client as a feature, so we wouldn't use the tree. Okay. And by gracefully support, I imagine like client heal. This is one of the places where I've been like trying to figure out where I want to take a position on it. Because again, this is like I've been nerd sniped by Quick, and like part of me starts getting to this zone where I'm like, should the client be able to heal? Because that would presume that certain code would have to get to the client eventually. So I mean, I started this progress in 1.8, and again, I don't know if it's completely right, where I started being less forgivable for hydration mismatches because I think ultimately we're like it gets us to a place where like we shouldn't have the expectation that all the code will make it to the client. I know this is like thinking like really far out, but and it's less happy place, but I mean it's kind of like one of those like stick your foot forward and this like hope it you can keep on walking. I guess we'll see. I think people should like the stream. Yeah, I agree. Like, subscribe, follow, comment. I don't know. Very much appreciated. So yeah, this is an interesting thing. Like there's a couple aspects of the solutions that lead to this, but I wanted to point out that it's compounded to have different content for the server than the client for better UX in the case of progressing, which is the line to the future installed. Okay. Yeah. Um, yeah. I guess it's a question of whether those kind of situations should be special cased as to guard future features for cases where they should be the same, which is, I think, the majority case. Yeah. But yeah, progressive enhancement's an interesting one. Or what I like calling it, graceful degradation is like what my favorite term for progressive enhancement. Anyway, what I'm pointing out that the ID here is actually mostly for less like I know we're looking at DOM elements here, but mostly for linking up resources in this case, right? Linking up async fetching. So you like when you do the re-render, you're like, it's the same one, right? We don't need to necessarily render this into the HTML, but the fact that like when you make the structure again and you can find the async thing, you can match it up automatically. Otherwise, like you could also say user, provide me a unique key. You could be like, what is this query called? Then you could match it up too. But this was like, if you want, this is one way of coming up with a unique key in a tree. Okay, so I think this is probably enough preamble to kind of get like where I'm coming into these problems, because I started a while ago kind of coming up with like different approaches here, and I wrote a bunch of hack MDs, and I want to talk about a few of them today. One of them was my 2.0 SSR plan, but before that, let's talk about I like spitballing out, and I'll share this in the chat, ideas like sometimes I I think it's an important exercise where you go, can we do something just without it? Like get rid of it. Like as you guys know, when I was working on async, I wrote a whole bunch of stuff. It's like screw transitions. I don't like transitions. Let's not do transitions. What would the model look like? So sometimes it's useful to kind of go through the mental exercise. If you take something you assume that you need and you just get rid of it, and that is kind of where you have to start here, because I just went through a whole tangent about suspense or boundaries of some sort being the governor of how we do streaming and doing async and SSR. So the first question is, can we get rid of them? Can we just do SSR without async, without boundaries? And let's talk through that a bit, right? So yes, the short answer is yes, but I want to dig a bit more into what makes sense or not, and consequences of different ways this can be handled. which brings us to our first question. Should we wait for async when we encounter it outside of suspense? Yeah. So what I mean is if you just have, yep, an early stream, yeah. This might be my new time because of school pickup and drop off. So and actually on Twitch, am I streaming the right category? No. Every time StreamYard switches me back to um, talk shows and podcasts, really annoying. Sorry, just a second. Let me update that. I want it to, what am I? Game development, software and game development. There we go. Finally. Okay. Okay. Let's. So I always forget to do this. Anyways, let's continue on. Where were we? So this is like we were looking at our async example, when I was talking about this async fragment and I was talking about like, doing data fetching or doing stuff, you know, is it possible for us to just like forget about the boundaries and just how could that work? Because in a sense, one way of knowing we're done is by putting a boundary around it. Another way is collecting all those promises that are in the UI and deciding when we're done. So basically, if I go here, I go, which first should wait or not to wait. Solid and RCs have taken the opposite approach here, but Solid 1.0's approach didn't wait and didn't really work in a lot of cases. Basically, we only lazy consistently worked. So async SSR without suspense was basically no go. In Solid today, if you try and do async without suspense, it doesn't work. If you've seen in RCs, what they do is they actually almost have like an imaginary suspense boundary around the whole page. So it actually holds, like the old async hold. Like if you don't do anything, you just put async on your page with RCs, like make async component. It will do that behavior that nobody likes where it waits till everything is rendered and then sends it back, which seems like a reasonable default. Although client side, that doesn't work, right? Yeah, so what I said, this is pretty convenient is it lets opting in to be more gradual. And Next has used this to do things like PPR, right? Because they basically assume like if it's above the suspense boundary, it's like static. That's essentially the gist of PPR. But RCs are not isomorphic. They only run on the server, so there's no consequence of them behaving this way. They can't update the client. If a client component under them were to throw a promise and no suspense above it, things would not go so well. Because as you know, in React, if there's no suspense boundary to catch it, it crashes, right? In Solid, our async model doesn't require suspense boundaries right now. So it's funny that we're like this weird opposite. But Solid's async can work without suspense in the client. It isn't a great experience, but it won't crash. So does it make sense? Well, if it is held on the server, then we know that by the time we hydrate, we'll have all the async values resolved, which means that any future update will tear predictably. In a sense, we just skip the fallback and continue from there. So waiting does work, well, at least on the surface. What happens if we encounter new async? Lazy or data fetching behind a conditional? Then we're back to square one of not having a suspense boundary above it and no fallback to show. Yeah. So what I'm getting at is, does this make sense? I'm just to throw a playground out here so you guys can see what I'm talking about. Is what if let's pretend that this. I'm just going to add something else. Let's just go const async data equals create async. And I'm doing this in solid syntax so you guys can understand what's going on. If you're familiar with this stuff, fetch something. What happens if we have something like this? And we're like pretty happy that there's no suspense boundary, and we've simplified things. But then we have some code that's like, I'll use solid show component. It could be a ternary, it doesn't really matter. But it's like show when count is bigger than 5, and let's now show async data. So we didn't need this data to render this page because count was 1, which is smaller than 5. We skipped right over it. We don't care, right? But at a future time, when count becomes bigger than 5, there's no suspense boundary for it to fall back to. That's all I'm getting at, is like RCs don't have this problem of future because they only exist for the length that you're rendering the page when you're on the server. You don't have to worry about this like client interaction. But if you're like talking purely client side, if you need suspense, you need suspense, or you don't need suspense, you don't need suspense because of the potential of new discovery. It's not as simple as saying that, it just works this way the first time. Does that make sense? You guys following here? Because if you hit that new async, it needs to go to fallback. It can't resolve it. It does not have the data to show it, theoretically. Now, this isn't like the best example because technically speaking, this async fetches eagerly in Solid's model. So like when it enters the new zone, it will have the previous value. So it might like in Solid 2.0's like model, this would actually work. But like you could picture if the data fetching was underneath the show component. So like there's no way for it to fetch below like before this ran, like it wasn't eager like this. Then yes, you definitely don't have the value. You definitely don't have anything to show. You like you, this is a situation where you would go up to suspense. Now, obviously, we could say like you don't need suspense in Solid's model, but you understand like this is a suspense situation where you could show broken UI. Like I think we've talked about this before. Like one of the classic problems here is like if you put a div in here, sorry, div, and yeah, everyone like inserts are easy to picture, but like what if it's like class equals some class some class like what if it's like this, like the tearing here could be unpredictable if you don't have a boundary involved, right? Because it's like don't get me wrong, there's transition models, there's other ways you could solve this, but like a naive tearing approach here will show the content without the class being applied until the class is ready. Like it's not enough just to be like, oh, sorry, it's not inserting anything, you know who cares? It's just blank. I mean, that's not always the best experience, but you can actually, if you have async stuff and you just like skip without showing suspense, you can end up with weird holes. Not just like, there's some content not loaded yet, but like a class isn't applied or a source is missing on a link or something. You know what I mean? Like you could break in ways that you have no idea you could break. So we talked about this previously on stream. I called it unpredictable tearing. Okay. All right. So okay, is not waiting an option? So we talked about what would happen if we just were able to wait and not do the suspense bounding. So it's not waiting an option. Render string has no ability to do anything but return a string synchronously. So if it encounters async, its options are limited. It either errors or returns with holes, right? We just talked about it. The other position, if we want to just stream the data, not the HTML. Yeah. So what I was saying is, what if in a situation like this, the expectation is, again, this isn't a great experience necessarily, but could you just stream this out and then have the stream the data in from the server, and then when the data gets from the server, basically client renders the rest? That's kind of like the hypothesis here. It's worth pointing out there's a difference between no suspense and no async reads. It is possible to do async and not trigger a read via some sort of guard. Yeah. So what I'm getting at is conceptually, um, we've been showing this off on the Solid 2.0 Signals 2.0 stream, this idea of like async guards, but you could build a system where you're like, hey, don't trigger suspense under this condition. So it is, I do want to point out there's a difference between saying like there's no suspense and like and no guarded async. Like this can at least inform you that it's intentional. Like here, you don't know what the person intended. This is a messy. But if the condition was like show is when not is pending async data, this conceptually is like you could say without this you could consider that like an error, but like with this you can say like, look, we're informing that, hey, we care if this is async and this won't trigger, like a suspense. We're taking care of it ourselves. You know that this won't render until this is handled, right? So like there's a difference between this and just being YOLO, right? You could say that the YOLO version still is an error, but this version is fine because it's actually informing intent, and it's explicit. So of course, to do so is pretty intentional, but it does differentiate things so we control what we can't. The difference with guards is that they won't trigger suspense anyway, so they'd have to work if we were to have them. So in some ways, this doesn't impact our decision. And since there's a way to, maybe there's sufficient data streaming solutions. Can they work? I guess it's a better question. Like maybe these avoid suspense APIs, maybe these avoid suspense APIs are untenable. My biggest concern I see here is hydration. If the data hasn't resolved yet when hydrating in these cases, should be more or less okay since the HTML and the hydration state will match. But there will be some places where this could fall apart. So what I'm saying is like, if you assume that this hasn't loaded when it flushes, you're just going to get the button and then the client will be able to just render the rest in. Right. But if the data loads before the render finishes on the server, then you might be in a state where you actually have the data on the initial flush and you'd have to make sure that the client was communicated that information. Like, what if some case the data is loaded and the others it isn't? Like maybe it's in a cache. If they aren't present at flush time, we won't wait for them, so they won't have update on the server release. Though through some combination with suspense, they happen to be, then I assume that the data will have been sent to the client by the time that boundary hydrates anyways. The other issue is data loads before the client is able to hydrate, but wasn't present at the time of server rendering. This is the more critical one because I feel like this one you could like do something smart. It's a bit awkward if you went to hydrate expecting the HTML to resemble the data not there, but then the data happens to be there. Like it's possible that it takes longer for the JavaScript to load on the client to do hydration than like the stream of the data comes in. So like you almost have to replay the events in the exact order that they happened. Otherwise, you might hit an issue where you actually have the data and you go to hydrate and the rendered HTML didn't have the data and there's a mismatch. Like the server side would have to mark things not read async under suspense versus things that are. But what if in one place it's red and another isn't? What if under those is different boundaries? Yeah, I kind of go on and talk about like complications with this. Technically, I mean, you could take a stance that if it initially renders to not available, you hydrate it that way always, essentially. But like it's tricky if the same asyncs read under different boundaries. I mean, I'm not saying it's unsolvable. I'm just talking about lots of complexity in terms of making that decision. Um, Technically, the scripts appended at the bottom of the page run synchronously and in order, but they don't trigger actual hydration because the async page scripts may not be present yet. We'd almost need to have them be blocked by hydration to process. It's interesting. Lazy is another interesting thing, as it isn't something we can just serialize or haven't until now. Currently, server finishes and serializes data triggering suspense to hydrate, but lazy code may not be present and interrupts it. Yeah, what I'm getting at is server-driven mechanisms are where when the server's done. So when the server has rendered the code, when the server has loaded the data. But if you're kind of waiting to be able to for data load to be able to kind of hydrate synchronously for portions like different boundaries, it's kind of awkward that the client might not be like a lazy component is a perfect example. You're importing code. On the server, you import the lazy component and you use it to render your thing. But the client has to also import it. So the fact that the server has imported the lazy code doesn't mean the client is imported yet. So currently installed, when we actually go to hydrate, we do it when the service is done, but the client might actually not have all the resources yet it needs. Which and this is a tricky problem from a bundling perspective too, right? Because you can have the same lazy code have different hashes between client and server. So like it's not as simple as being like have the server being like, hey, we're gonna need this, so load it, and then when it's loaded, that's when you hydrate, because the actual file name could be different for the exact same chunk from client and server. So Yeah, it's interesting. Like right now, what Solid does under suspense is we hydrate synchronously. It's a lot easier. It's hard to have stuff hydrate coming in at different times because you have to kind of enter and exit hydration mode. And lazy components are one place where we do that. And I think it's messy, where it'd be great if you can just say, like, I'm going to hydrate when this block is completely ready. And that includes a client side stuff. But because of asset management and bundling, this is actually tricky unless your server side rendering system is actually aware of how things get mapped by the bundler. It's not beyond something that that I'm thinking here. I know Nuxt has a trick where they actually compile in like unique identifiers on both sides, like because you can always use the source position in the source code because that's the same before like it's bundled out like into the different environments to actually get a constant identifier that's the same on both sides. But that requires processing of all your files and not just like some JSX somewhere. So like there's there's again manual and then compiler based solutions, but it adds this kind of layer of complexity. If we could hold off hydrating boundaries until lazy code is loaded to make things easier, we need then code where suspense relied on certain code and hold off to it's settled. If we want any particularly in terms of data resolution hydration, we need to run the whole boundary synchronously. Yeah, bang. Okay. So is no top level suspense a thing? It seems not waiting is complicated. Technically, it could work, but there are a lot of edge cases unless we basically replay the timeline on the server on the client. I also don't think, unless intentionally guarded, not waiting is behavior we want. Waiting works in the simple cases, but falls apart when something new happens under a conditional. But this is always a problem, even when with tearing async, and it isn't really an option for rendered string. Suspense at least sync bails out. So maybe all of this is more about setting more general rules in perspective. Let's create a hypothetical rule set. On the server, render string requires top-level suspensive guards. It doesn't have any complications with timing since it needs to fetch on the client anyways and doesn't wait on the server. So we just error out if unguarded async makes it to the top. Right. Because the thing is, you don't have to worry about async hydration with render to string type method for rendering because you know that you can't get more HTML from the server later, right? Like it literally, it's over. Once you've got that synchronous chunk, you're done hydrating. Other render methods wait on the top level for async. We need to consider if we should respect a guard provides. In the client, user effects can handle async without suspense. Unresolved async read in a render effect with no parent suspense errors out. Unresolved async read since under suspense transition can be guarded. A new unresolved async read under an existing suspense logs a dev warning suggesting to use Nessa suspense or a transition. What this would do is SSR would work without suspense, but the second someone did any new async used in rendering outside routing, which is done in a transition which is safe, it would error. So basically, if someone just starts adding random asyncs under conditionals without boundaries, it would break. Does this save us from needing to first numeric async? Only if we value was read in the topmost suspense. This is something that could happen with meta tags, I suppose, worth exploring. So I think you could have an application with no suspense if it was very basic, i.e. no major UI changes outside router transitions. But even then, I'm not sure this would be great. But as a baseline, that can be a reasonable with run once. But almost immediately beyond that, you'd have suspense, and we probably need to be pretty aggressive in directing people that way. Yeah, there's some fun with that, and honestly, we're in a weird, as I said, we're in this place where like we can start using compilers to solve everything at this like level, and I've been resisting this as long as possible. Like philosophically, people don't solid is the probably nowadays the least compiled of the main frameworks, ironically, because React now has its compiler. I would say React and Solid were about the same before, but we actually use compilers less than everyone else. Even though when Solid came out, everyone thought we were like Svelte, but we are not. We are the least compiled JavaScript framework, ironically. I really, we I think as long as you denote things for compiler explicitly, it's fine. But it is dangerous to like where edge cases come out when you have like implicit behavior around compilation. Yeah, I mean, I thought about SSE for a while because one of the problems is you can't guarantee that you have persistent state. You have to assume that 90% of people can't like are not incapable of opening WebSockets. So it can't be the general solution. Like it's great where you can, and I have people on the team like Dev who are very deep along that lines. But generally, average person throws something up on a Lambda function, does not get WebSockets. So um, it's tricky. I mean, I tried. I don't know if more server client communication. I mean, it is. We can still play along that original stream. I think we just need to. The server has to be aware of the client bundle. That's the gist of it, right? As long as the server can be like, hey, you're going to need this, then we're fine. I just haven't found a generic solve for this yet. It'd be amazing if I had a generic solve for this. Like we already have the protocol. The initial HTML being rendered down has the capability of doing all this without opening a second connection. Yeah, I mean, we say that, but then we're going to talk about the async proposal in a minute. Svelte definitely see. It's kind of interesting. You say like Svelte's more runtime, but the thing is, Svelte now compiles files that aren't just Svelte files. So in a sense, the scope of their compiler has actually increased, which increases the potential of edge cases, I guess to speak. So like there's a I guess the what magic means different things to different people, but like the bounds of compiler are an important aspect. Oh, really? I thought you already had suspense boundaries. Okay. Anyways, it's so funny. Like we're I'm kind of wondering if Dan Abramoff's right, and we'll get to this in a few minutes. It's just funny. Solid was the only framework of the big ones, like and we're not big, but like fifth, I guess, or sixth, that actually implemented transitions alongside React. Um, back 5-6 years ago, and everyone told React they were wrong, and I was like, no, React's transitions are good in a certain use case. Just the one that got demoed by Dan with the stupid radar thing is not that use case. There's a huge value to them. It's just, but most people are like, no, we don't need this, and it's like, we'll talk about it more. Okay. So yeah, anyways, what I'm saying is we could kind of let people get by and then kind of like error on them to direct them the right way once they get there. So, but that's like, is that the reality we want to live in? What we could also just set rules and be like, no. As I said above, I think the ideal world suspense boundaries would only hydrate when ready, which relies on execution for the server to gather async resources. Since code CSS other assets are not things we can just serialize, I believe we need to communicate to the client to load these assets and hold off things until they are ready. It's tricky though, because I believe it's possible for lazy imports to have different hashes to client server to map them yet. So what I'm getting at is, I'm wondering if in a world where literally, how Vite has manifest for client to server, where like we expect a format like that, and then we're like, okay, guys, I know this is kind of weird, but our render to stream or render string to actually work properly, like right now, you say it's an optimization, but to actually work properly, you have to pass in your bundler manifest. I don't know if I want to go that far, but it would make my life infinitely simpler. I think, like for me, I think that's preferable than say come up with something where you go and compile every piece of code and hope that you hit them all. Yeah, I mean, it's interesting here talking about magic is like technically speaking, I agree. When hooks came out, things got much more less clear for people. Pre hooks, React was really easy to explain. Post hooks, the fact that this thing is persistent in the background is harder to picture. I mean, it's not that hard to picture. You can think of context as a perfect example of where React does this later, but um, it definitely that was the point where people stopped being able to just like go like, oh, I feel like I could write something like React in a weekend. That's when people are like, what the hell is going on? Yeah. Definitely from the fact that they are no longer using the compilation to do reactivity, and rely more on runtime. It removes some of the like it just works kind of magic aspect. I just meant like the scope of yeah, it's I guess it's less magical, but the scope of compilation has increased. So it's like the concern about how invasive it is are still there. I mean, at this point, from an output standpoint, like view compositions felt view with vapor felt like we're not really that different. I think there's a philosophical thing we need to look at in terms of where it sits. But I mean, well, I mean, most people know this. Vue had a proposal for something that looked basically like Svelte runes, like 4 or 5 years ago around because they saw Vue was like we have this fine grained reactive system with composables, and then they were like, huh, everyone's going to Svelte because it's easier because of simple syntax. So they tried to apply, um, their own dollar sign syntax to Vue. It was called the ref sugar thing, and in the end, runes and that ref sugar look very similar. I know because Alexa saw the Vue proposal and made a library for Solid 5 years ago for the same kind of thing. So, like in a sense, now we've gone to a point where the baseline is all very similar. Yes, yeah. I think that's fair, and in a sense, Solid hasn't leveraged this yet, but we were kind of using like we can use the .jsx extension if we wanted to do that. Like essentially, we could say we only process TSX or JSX files. So I've considered this, and I think this is yeah, yeah. They deprecated for the same reason that I didn't merge it into core. I thought it was worse than the problem that it was solving, especially when you start thinking composition and they start having these double dollar sign out things. What Svelte did come up with a well, first Svelte 5 didn't solve the problem, and you had to, you know, pick your own wrapper, which I think was better than the dollar sign to be fair. But then later they got the class mechanism for kind of auto compiling to classes, which is a little bit nicer ergonomic than the dollar sign. But I mean, obviously, I still stand by my original position. But I'm free to have my opinion, which is different than others. I do think what runes solve personally isn't worth the effort compared to like the problem. Like the problem is as bad as this, or the solution's as bad as the problem. But that's just like my personal thing. I can see why some people would think differently. Um, Anyways, that's the first of our SSR discussion today. So I think that the highlight on that one is simply suspense is probably just a good thing to have. Um, yeah, because newborn and kid pickup times and stuff, I'm probably going to start streaming earlier from now on. Yeah, that's true, and that's the same problem we had with signals early days. They weren't even compiled, and people thought they were magic. It's but what's interesting is once you know, how do you feel about it once you know what the transformation does, right? And the other question is like, how much do you need to know what the transformation does to actually have an accurate mental model of how this thing works, right? Like my favorite example, although that's the class compilation thing fixed it, but like favorite example was if you made a like a dollar sign state ruin and you return it out of another file, you had to wrap it in a function or in getter or something, right? And it was like, why? Right? If basically the abstraction didn't protect us from having to know that everything reactive is a function. So like at that point, that's when I asked the question: is it typing two less characters worth it compared to the cost of abstraction from a conceptual thing? When it, you know what I mean? Like you, if you have to know how it compiles anyways, then what is it doing for you? As I said, different ways to solve that. Different ways you can just go deeper and come up with different mechanisms to hide that or that. But like that's the sort of question. It's right. Sometimes. I hope so. I mean, I'm a big fan of proxies, as you know. Yeah, when you know the transformation, it does stop feeling magical, but then you also have to ask the question: does it feel worthwhile? So it's like it's a tricky one. Anyways, um, so let me see here. Where was I? Right. Okay. So I have back in February or January, I set out two things I wanted to fix with Solid's async, and this is again. Let's get in this mindset. Um, and keeping what we know in mind, I pinpointed two issues with our async, our SSR. SSR doing re-renders on the server. While Solid has been so fast rendering on the server, it didn't matter. At a certain point, somebody's like, "Look, my memos are expensive, or some of the things that I don't like keep with those resource IDs are expensive." It's not expected. In Solid, everything runs once. Why on the server does this component now run like 3 times? Because of nested suspense boundary timings and stuff. Usually suspense is kind of blocking, sort of, because of, stuff failing out. But actually, that's not because, whether it's an undefined check or throwing, like usually it's like something is blocking, but some cases it's not. And this is like that problem that React had, right? Because originally they were like, "Hey, we just process all the siblings and continue on our with our merry life." But then, as when they released React 19 RC, some point in the middle, they'd been like, "No, no, we're just going to stop on the first async," you know, and because it saves time, we don't have to render the whole rest of the thing every time. Well, Solid does render the whole rest of the thing time. Maybe it renders 10 times faster than React, but it still renders, right? So like that's something I wanted to fix. And then the other thing was like hydration IDs in the templates. I you guys may remember there was that benchmark thing, and it drove it was a little bit. I spent so much time optimizing Solid SSR down to the JSX level in bindings that when you turn off hydration IDs for Solid, it was the fastest server-side rendering in that Fastify benchmark. It was faster than someone who just doing a naive template literal. It was basically faster than every other implementation that they had there, even just like using a string in Fastify. And you might be like, how are you doing this? Because the compilation, we can be smarter than just using a tag template literal. You guys know tag template literals hold memory around because they keep the arrays in memory. Like this is how lit works. Like every time you run the tag template literal again, it actually has a reference to the static nodes, and then you can put your bindings, basically attach it to there, so that you don't have to like redo it. That's why lit can re-render over and over again without a virtual DOM, because it actually keeps the static references. But in SSR, do you want to keep those static references? No, it runs once, presumably, in a fast benchmark. So, like, there's a lot of places where you can optimize performance. And I basically gone very, very fast for Solid SSR. Then you add the hydration IDs and the size of the serialization offset it. And instead of being 30% faster than every other framework, it was, like 10% slower than the fastest. So, I mean, this is a minor gripe because it's not representative of real world applications, like creating 2,400 elements, in a tight loop, causing, as I said, we do chunks. So there's an ID per element. But, if there's a place we can improve, these are two areas, right? So I've kind of been working on two different solutions to these problems, and I want to kind of talk through them in terms of designing them. Um, One of them was the first one is what I'm calling pull-based SSR. This is very, very inspired by what I showed on stream. If you guys remember, I had a stack blitz from a previous stream, which I have not signed into for a while. Can you get up? Where I was showing, yeah, I think it's this one. Whereas showing this example with like the self-healing error boundaries, right? If you guys remember this code, I wrote something where we have some signals, we have some async, and some memo that transforms that async. And essentially, there's a suspense boundary up here, an error boundary down here, and inside that, another suspense boundary, and some kind of async thing we're doing here. But my point is, what would happen is when it throws or errors out, um, even though the data fetching is way up here and not related at all, could be in a different component, we don't really care. Because it's in an errored state and the error boundary collects the render effects that error out to know if it's thing, we have the ability without rendering this component to both when it errors, see, both either retry, which essentially just says pull again, just ask for uh for the data. Like it basically just tries the data fetching again automatically because it goes, okay, this async has failed, let's pull, right? So, doing this, or without rendering again, let me get another error. If I click here, it also clears out the error boundary state because it goes, oh, the node that we previously collected, well, it's no longer errored. We can remove the error boundary again without re-rendering anything. So like essentially I was very inspired by the work in this zone because I was like, if we can just collect the things that aren't ready and just try them again, we know when we want to try them again. When async resolves, couldn't we just do our SSR this way? Couldn't we just SSR is concatenating a big string, but until we combine it, it is an array. If each hole could be resolved independently, templates are the sinks similar to render effects. We could combine as best as we could, leaving some holes where async. And as the async resolves, it approaches one string. If we separate creation from polling, we shouldn't have to rerun any components the same way we don't need to rerun with suspense. It just pulls out the expressions. We don't need reactivity as promises themselves can repull. What I mean is it's not push based. It's not push pull. It's literally just pull based. It's basically identical to client resolution pattern, but it doesn't since it doesn't update, it only needs to resolve once, right? So basically, you collect the nodes that aren't ready and you pull. And it's yeah, I'll talk about more in a minute. The other idea I had was the reason we have hydration IDs in the templating is because of JSX can be created out of order. See, Svelte has this and Vue have this advantage over us in terms of hydrating because solid can do this, which is a little bit awkward. Solid can do this. Don't get me wrong, this is a freaking superpower, but solid can do this. Okay. Still works, right? You can literally create a div with a reactive binding up here and just stick it inside the thing here. Like I can create my JSX in any freaking order. I can import it from somewhere else. I can bring it from, like this is why I love JSX. I think JSX is incredible because it's incredibly portable. You can literally just go like pick it up and toss it around. Obviously, we tell people most of the time in Solid to do this because the advantage of doing this is that some people make the mistake when they see this to think that because it makes a div element and they might do something like this. And if you know anything about the DOM, an element can only exist in the DOM in one place. So doing this is not good. It doesn't really work. Whereas doing this, I must have TypeScript turned off, does work, right? So it's just something to consider. And in a sense, this does defer the load. But my point is, it is always possible to create stuff out of order with JSX because it is portable, right? Even in this scenario, what's the order of creation? Oh, I want the client side output. What's the order of creation here? Okay, yeah, so it does create the button first. Okay. Good to know. Okay. But generally speaking, this aspect of GSX is incredibly powerful, but also sorry, these aren't but also as you can imagine means that we can't just like we don't know the parent. I mean I use this as an example, but you can picture this even conceptually here. When counter gets called, we have no clue necessarily who the parent is. We can't say you're going to be inserted into this. Like who's the parent of div? And like even if I wrapped it in a function myself, how do I pass in that information? Like now this is a component conceptually, right? That's all I did here. I just made it a component, right? I mean, I called it as a function, but this is conceptually a component, right? Um, like how do I know what the parent is? And you don't because it's potentially unless like we pass something into the function to tell it, hey, like when this is actually is a component, parent is the first argument or something. Unless we did some kind of like advanced compiler, not even advanced, but some like extra compilation information, we don't actually know what the parent for any element is. Is div variable works on client side? Yeah, I mean, sorry, I don't. I mean, technically, this works with SSR too. Um, what I'm showing off here. Um, this is just like a fact about GSX. See if and part of it is like because you can also have like 10 components on the page, right? Or like in this file. So like it's just a function. So when you have a single file component, you can be like, look, there's rules. We can control what things we export. We can massage the signatures to fit our stuff. Like this is why a long time ago I said that I think that single file components have an advantage for SSR. They don't have any advantage necessarily for client, in my opinion, but for SSR they have this advantage because of a certain amount of analyzability, being able to control the exports. They could even have advantage also probably for like hydration as well because of this extra layer. But as I said, the portability of this is just unmatched. I can make 10 child components inside my component that I like. It's just it's super powerful. It's just it restricts us on like very specific rules. So um So the key challenge is we render, we need to collect nodes so they can appear in effects expression. This happens early in the template, but what if we didn't need to? So I had this other idea of like, what if we actually proxied elements while we created them and then realized them during hydration at the end? I'm going to go into detail on both of these, but essentially this is the kind of like the hypothesis I had in it. I kind of came up with this kind of, I think over Christmas break, and I wrote it down sometime in January. So let's explore deeper into both of these. So let me share this one. This is called pull-based reactivity for SSR. Okay. The idea here is if that we can avoid component re-render. Sorry, my headphones are not coming through. Oh, do you know what it is? My mic's quiet today. Nobody told me. Sorry, my mic's been quiet this like whole stream. Oh well. Is that better? I'm now I've like probably blew everyone's eardrums. No. Sorry, my mic's been very quiet. Okay. Well, hopefully that's better. Okay. Okay. Well, you guys there's probably some like built-in compression on something or other. So I don't know. It sounds better to me. I sound crisper. I feel more dynamic range in my vocal envelope. Okay. Okay. So okay, the idea here is that we can avoid component re-registering SSR by repulling the result as async results. The idea is simple, but some repercussions to the system. Let's look at designing this works. Right. So what do you think? If we're going to do a pull-based system, what are some design considerations we have to consider? Well, first, that if it runs once, nothing but async state can change during SSR. or things derived from async state. There's no notification, no push-based reactivity here. So if a value would be set, it has to be during initial render. Since events and effects don't run during SSR, you shouldn't be writing during the pure part anyway, so I think it's fine. What I'm saying is, and we have this constraint in Solid today, like it kind of works because sometimes things re-render, but you shouldn't like create memo and have it write to a signal like that's higher up that happened to like already render some stuff. It might not update, but so it's a prime thing here. You shouldn't. I think the reactive system and reactive rules generally have you here, but this is a good assumption and thing to put forward. I don't know if you guys have situations where there's like, it's one thing to have like a signal and then like a crate computed right after that writes the signal for initial values sync with props because you haven't rendered or used it anywhere. That would be fine. But with Solid 2.0's design, we're avoiding that anyways, right? Because instead of doing, just scroll down here for a second. Instead of doing const name, let's use name, set name equals create signal, and then be like create computed or effect or whatever. Instead of being like set name props dot name, right? Instead of this being a thing, the Solid 2.0 version of this is name set name equals create signal props.name, right? So you write like you're already in a zone where we're saying like don't call the setter, right? Like this, like at least not like the only other time you'd be calling set in these types of examples generally is like when someone clicks a button or does an effect or does something, and those don't run on the server. So technically, this should, I think this assumption's a safe assumption. Okay. We need to be careful to watch on performance. Not collapsing to strings seems to have a negative impact on performance. Our pure string approach appears to be the biggest difference with Solid, say from others. Now, to be fair, Svelte does use a string approach, but I don't know a pure string approach, so I actually think the performance is actually pretty similar. I don't know why I mentioned Svelte. It should be. I think I meant to say a different framework here, but it's. It is we don't have any intermediates, and some of the other two strings like actually do have intermediates. So this introduced an intermediate again, which is slower. And I actually benchmarked this, and sure enough, it is slower. At least in my naive approach. I'm thinking of how we can make it faster, but it is definitely it definitely takes a performance hit. So looking at SSR template functions. Right now, a tag template literal, that SSR function I showed you, and it goes through stitching strings with holes that can be strings or numbers, functions, i.e. reactive values, objects with T, which signifies that they're already processed template, and arrays of other value values. So yeah, this is part of why we had the SSR function. It was because you can put the previous example here, where you put JSX and JSX and JSX like this, and we handle it generically. We needed a way of being able to say like, look, this has already been escaped. Don't escape it again, right? If we look at the server-side rendering of this, see how this calls escape around create component, because it doesn't know, generally speaking, and around count. But count will not be escaped twice, because what gets returned from this SSR function is a template object that will pass through this escaping. It will assume that it will be like, I've already been escaped, I've already been processed. So this is kind of key to what we were doing for our design here. And then it can also be an array of other valid values. So yeah, I'm talking specifically here about this SSR function that I've been showing here that kind of stitches the strings together. So it's conceptual here. And we assure that all objects become and we sure that all becomes an object with T, which carries the string. Solid today doesn't even really compile the functions for these native templates because they run every render like React. So we have, for the most part, just been jamming strings into objects, which then jam into strings as we compress up. Why objects? To prevent double escaping. Escaping assumes that these are processed in the easiest way. As it turns out, not compressing as we go is slower. I.e., if we keep our object around a long time, then compress at the end, it's actually slower than compressing as we go. So Unsure if we have any options with async. We need to see if string replacement is faster than objects, because with async, you can't melt everything into a string without at least markers. Yeah. So another option you could do is, instead of keeping these objects, like unresolved arrays or holes, you could actually just like make markers in the string and replace them. I don't think this is faster, probably at a certain point, but it's worth a question. Concept here is we compress the best we can, but then we rerun any remaining holes when async completes. As we run our SSR method, we try catch each hole. If it throws not ready, which means it's like got a promise, it's async, we can't flatten to a string and return a template with the resolve string with breaks for remaining holes, the whole function to rerun, the ownership context of this template, and collected promises. This is the tricky part, because you have to resume context or the reactive ownership scope when you rerun these holes. Parent templates may come across children in the state. They too can flatten best they can, combining resolved values and templates to holes and waiting on promises. However, they won't try to rerun incoming hole functions and unresolved templates. This combining suggests that holes may need to keep their own owner reference, because once combined, adjacent holes may need to run in different contexts. The responsibility of rerunning these holes will fall to suspense and at the top level. Effectively pseudocode. So what I kind of pretended I wrote this function to kind of get an idea of what it's doing. It's like promising all the templates promises while true, and then it gets the result, which puts the first part in, and then makes a new collection for promises holes, and then goes through the templates holes that currently exists. So the thing on the template are what's current, and this is like for the next iteration, what it collects. So gets the template holes, tries to resolve them, run with owner with the owner that's passed in, and then if it doesn't throw, essentially append it to the other part. There's a bunch of logic here. It's not too important, but I think you can kind of see how it's like basically pushing the stuff along and combining as it goes. And then if it catches an error of not ready, this is basically our promise error, we rethrow. So we rethrow any error that's not that. So go to like error boundaries and stuff, right? Otherwise, we assume that it's async and we just push the current thing in instead of merging it in. And then finally, if at the end, if there's no holes, we can return the result. Otherwise, we update the template with the new list, and we do it again. It's pretty cool that SSR becomes a do while true loop. I mean, this is kind of more conceptual, but the point is like, it just sits there doing it. We kind of created a generator, if you think about it. We're just sitting there and we're like, while true, await all the promises. When the current ones are finished, go through again, try and combine it. Is there any more promises? Do it again. And just basically until it can sort it out. But what's cool about this is, as I said, is it's just rerunning the holes in the SSR function. It's not rerunning any components this way. So how does this work with suspense? Well, suspense returns the fallback without returning a template with holes unless the fallback itself has holes. So this means that the parent can fully resolve and flush, and stream it out. This means that suspense boundaries do still need independent registration so that when they complete, they can flush themselves, as well as potentially, if they finish before other elements of their parents, do the string replace. What I mean is we have this mechanism, we have it now, where if the child suspense finishes before the parent suspense, we combine it with the parent suspense, so they all get sent out on the same thing. But because it's already reported to the parent that it has its fallback, we have to go in and swap out the fallback with the finished content. And again, we do this on the server instead of waiting for it on the client, just make it a little bit faster. And that's all I mean here. It's the reason that we had to do that swap is because we've already combined it into the finalized string, because you can always stream out a fallback. So it views itself as like finished to the parent's perspective. Anyways, in a lot of ways, things aren't that different than today for server rendering part. Hydration is a different question, but we'll get to that. One thing that could be worth trying is not keeping what I call the parts above in an array, but instead put them all in a string with some sort of noise marker and do string replace at resolve time. I expect this won't be as performed, but we have to look at object allocations. Like in the real code part, wouldn't be an array, it would be a single string, and we just upgrade it to arrays as needed. We might also need to look at monomorphism in terms of the shape of these template nodes. They are sort of like VDOM nodes, admittedly, but more like block DOM than individual, and only when things can't be resolved initially. So what I'm saying is, if you think about it, kind of like at a distance, each of those blocks of SSR functions that return these template objects are forming a tree when things are unresolved. So in a sense, they almost form a kind of temporary virtual DOM that then flattens as the async resolves. So we might be able to find optimizations from there. It's also possible the whole compress as you go might not be worth it in real async scenarios. The problem is I'm not sure we'd ever be able to tell because async already adds more delay than we typically capture in tight SSR cycle like benchmarks, and those being synchronous would always benefit from early evaluation. Yeah. I mean, this is what I'm getting at. Benchmarks are generally synchronous because async is unpredictable aspect of it, right? Like, so like generally they're always like testing how fast can I jam strings onto the page, which means that even though early evaluation is always beneficial in those cases, it's basically, it'd be very hard to measure that it wouldn't be. You'd have to come up with a situation in which involved async in a predictable way and figure out what was like maybe something very expensive happening after the async to really show the benefit here of this approach. This is one of those thankless approaches. React has a lot of these where they build something that doesn't end up improving any sort of benchmark, but it should be better because the execution model is better. So like yeah, I mean, it's always tricky. React compiler is actually one of those. If you think about it, React compiler doesn't make React any faster, right? So when you try and create any controlled scenario that's like at all reasonable to create, it actually doesn't end up with it being actually faster. But you know that when you put it out in the real world and there's messes out there, there is benefits to it. So it's like it's tricky. Conclusion. Anyways, this is basically the thought for now. Nothing really too complicated, nor did I anticipate it to be. The problems all come when we start looking at hydration. Timing is critical if we want to figure out how to drop hydration IDs, but given things like create unique ID and async serialization, we probably need to generate them anyways, even if we don't write them to the DOM. So there may be complications in terms of server rendering performance to consider, but I did confirm it was the HTML output causing the bigger slowdown for the hydration IDs, right? Like we could generate them and just not serialize them, and that was faster in benchmarks. That being said, none of this overhead is the big compared to the actual work needed in user code to actually present the data or to render the page. Yeah, I mean, the biggest struggle here is I think technically speaking on those like fast SSR benchmarks, this approach will be slower than the overhead of the hydration IDs, ironically. So it's funny where we're like, we could kind of saying like, you can basically make it so that there's a better, more consistent server output that works consistently with async the same way Solid works in the client, and it's actually like a better model. But we actually take a bigger hit than the actual serialization of the hydration IDs, which inspired me to start on this work in the first place. But we won't know until we've actually optimized it all. But this is where I'm sitting right now. Okay. And then, I don't know, I need to drink some water. I've started building the compiler this week for this poll-based SSR. There was some of you might have remembered I put a poll up on X a little while ago, and I was like, where is my profile? Why am I not seeing my profile? It's probably still here. Okay, I put this poll up, and I was like, hey everyone, experiments for Solid 2.0 now encompasses all approaches to client async stores and server, but implementing them all at once is a bigger lift. We could keep the current server and release it later in 2.0 or even in 3.0 release. Like what I mean by that is like we could just like keep the re-render server stuff like we've been doing forever and just like focus on the cool client side stuff I've been showing you, like this stuff, like the non-blocking async and all the cool stuff. And we can like do this new SSR later. And most people agreed that made a lot of sense. Unfortunately, like literally the day after I posted this, I came to a realization and actually re-implemented it. You can actually see it on the current next branch. I actually re-implemented server-side rendering, suspense, everything on this for SSR using the old re-render model. It's currently committed. It's been released, experiment 0.5 or whatever. We have fully working SSR not fully working hydration, but we actually have fully working. Well, technically, error boundaries don't work over suspense because I haven't re-implemented the that requires some hydration coordination, like throwing suspense, throwing errors over the boundary and having the client side suspense catching the errors. I haven't re-implemented that part yet, but other than that, like streaming, lazy, all the stuff works. But then I realized that I I couldn't hydrate it, and that it basically was going to be impossible for me to hydrate it. So that's why I am back here again, and why we're talking about it this week, because I'm literally writing the compiler right now for a updated pull-based SSR method for solid. So why can't we hydrate? Um, it's freaking hydration IDs again. Okay. Yeah. Yeah. Sorry. Comment earlier about the generators. Yeah. To be fair, generators can be a little less efficient, and we could write a compiler that did it, but then like this is just built in, so we can literally keep the same syntax and keep the same thing, and don't need a really extensive compiler. So yeah, async generators. Anyways, where was I going? Solid's use of hydration ID drew some attention last year when they were the only thing that kept it from being the fastest SSR renderer. Solid was even quicker than the baseline implementation being tested against. The reason being that it could optimize escaping with a compiler in ways that dump template literal that sorry, I said dump. I meant dumb template literals could not. So turn them off and win every benchmark. Well, not exactly. We need to hydrate in the client, and truthfully, we need them for other things too. Fortunately, it was only the serialization cost, not the generation cost, that really slowed us down. But it would be interesting to explore what we could do about the topic in the future. Okay, so let's get there. Staying in solid, they're used for two things: stable IDs for resource serialization, which we talked about, and for node matching for hydration. Right. This is the piece that people are familiar with when they open a solid site like Solid Hacker News. I don't even know. It tells you how long since I've opened a Hacker News demo. Why am I not seeing? It's funny. This is like the wrong repo. I want Solid JS / Hacker News. And let's go to one of my other branches. Let's do Netlify branch. Just do functions. You guys have seen this fun, I'm pretty sure. Let me see. Remember those 001s we were seeing in the React one earlier? I mean, here they are. Hydration IDs. Lovely. They compress well. I mean, but yeah, let's right. But the reason is because of I did a whole stream on this previously about hydration IDs, but because the JSX can be created in any order, conditionals, async, all the reasons that can happen. Essentially, the trick is when we go to hydrate, we collect all the IDs, so all the nodes, and then as the client re-renders in the exact same way, it will generate the same node, and then it like the node, same ID, and then it will be able to match it. That's basically the trick to our hydration. But the first one is worth talking about because create unique ID resource serialization requires them. And to be fair, React does something similar. This is important for automatic serialization to create resource. Otherwise, you need to provide a unique key or identifier. The only way you could do this would be some compile time mechanism we talked about, as isomorphism, different transformations on the code on both sides would prevent any sort of runtime mechanism from working. What I mean by that is they basically become different files with different hashes. So you have to basically, if you want to inject it, it would have to be compile time before that transformation. The challenge is, if you were to say come up with something to replace globally, like say $UUID, it would need to be presented at the call site. Like the following wouldn't work as it would produce the same ID. Yeah. So this is someone was mentioning arrays. This is another similar problem. Like pretend you created some kind of UID generation thing, and you said serialize with this ID, this value, and my serializable value. As you can see here, calling this function twice for 5 and 6 would end up with the same ID, right? So you can't compose the unique identifier. You have to actually find every single touch point that would need it. So it's not as enough to be like, I have one primitive where this is baked in. Like I can't just transform my create async or create resource to have a UID. You actually have to go to every single place that someone creates the resource and actually inject the ID alongside it like this. You might be thinking you could be clever and add a counter to it. But if order isn't stable, which is why you want this in the first place, that won't help you and you can end up with a wrong collision. Instead, you need to do it like this. Okay. Which means that the consumption API needs to provide the option. Basically, it's just a convenience for APIs that already demand unique IDs. This way, you don't have to think about what to name things. Less than ideal, but if serialization was opt-in, I could live with this, right? You can be like, oh, if you don't serialize, But definitely a mechanism that works runtime can hide these details short of a compiler going around augmenting all your create async, all your lazy, all your resource call. Problems, it sucks for composition. What if someone creates their own wrapper around create async? Then this falls apart. Like they literally have to use your lazy component. They can't make like my special lazy component wrapper that does, defers hydration or something. This is the problem I have with compiled solutions, generally speaking, is like they're very specific and often you have to be careful about how easy they can break. When you have to turn the thing that gets transformed into a special syntax, which is, again, to be fair, like stealth ruins $, that does it. Quick $, does it. You're saying like server $, like this, you're saying that this is not a normal function. It does not obey the rules of a normal function, right? It's not composable, essentially. That's the key to all of those primitives I just mentioned. The results of them can be composable, but quite often it interferes with the they can't follow the idempotent principle, right? I'm not saying that felt ruins aren't composable, but you can't via wrapper create the same thing again, right? Like I also use this example for control flow. Like my for, like in solid, essentially you can recreate where is it, like the for component essentially, but you can go const my for equals props return for props. Like you can conceptually, sorry, I'm missing arrow. You can conceptually do this and return the same thing, right? Same thing with create signals. Same thing with almost everything we do in solid. It has this, I don't want to call it like identity property, essentially. And when you have, let's say, template, I mean, again, this can be intentional, right? Sometimes the language can provide things that can't be composed over, right? But like if you have like hashtag each, if you want to make your own list component, it's going to be a component. It's not going to be hashtag my each, right? Right. Use directive, use server are another way to denote these things. But what I'm saying is you need to design a specific syntax for it that is a language level feature and not a composable feature. Something because when I make use server, you don't get to make use my server. So like there's implications of where you go to these things on a design perspective, right? React was hinting, although I don't think they ultimately went this way, but they were hinting for like their hooks that they use. We use create signal, but like the use signal for hooks, the use could be treated like that $. Like it is a Like they left the door open. That's why they told you all they put use in front, because you're like basically saying I'm denoting this is a language level feature. What's cool about use, for example, in this case, is that it can be applied to any primitive. So it actually is, um, it does have that um, identity property, right? Marco's tags API has that identity property. It's very, very, very important to us when designing it that every and again, this is not important to every system. That there's trade-offs to these design things, but it's very important to us when designing Marco that anything like anything you built could feel first party, like it was the same APIs, like that it had this identity property. So like what I'm getting at is most the problem with this, or with what I'm talking about here, is that you essentially get into like a language feature versus a compositional concern from a design perspective, right? Matching our addition. Now, this is where a lot of performance is. So alternatives could be awesome. The challenge is that elements in our template can be created out of order. In general, JSX executes out of order. We don't know the parent element over our children. We return our own markup and the parent attaches. In a VDOM library like React, we can construct this whole structure, then perform actions so order doesn't matter. What I'm saying is in React, they create all the VDOM nodes out of order, but then once they got the tree, that's when they hydrate. Like once it's in order. We either come up with a way to locate the element where they sit in the DOM in a way that the client runtime can find them, or we need to create some sort of virtual representation ourselves, is what I'm getting at. The third option, as I mentioned earlier, is that you could also like not create them out of order, like what Vue or Svelte do. But like for us, I'm saying that's not really an option. Locating with stable IDs is definitely the most straightforward. If we were to try not to use IDs, we'd probably need to serialize some sort of lookup, but even then the order of those calls would matter. Honestly, I think conceptually any solution here needs to convey the tree. So in a sense, hierarchical IDs are just the most compressed version of that information. As we're creating a VDOM ourselves, our code isn't designed to handle one, right? Solid only understands DOM nodes. I do have an idea of that using proxies. We can create our render tree during hydration, then get attached real DOM nodes. This is definitely more expensive hydration approach, suggesting a proxy per element that server render, but it would have no impact on SSR performance. You wouldn't be serializing it. I did a quick sketch with multiple elements in a fragment as a proof of concept. I shared this on Twitter and Blue Sky. I don't know if people understood this example, but what I did was I pretended that I server rendered this template, right, which is a div with 2 buttons in it, okay? And then I initialized the template twice and just put some values in it. So each button got their text. I inserted it to the app, same thing. So I just did it twice. The reason I did it twice is because I wanted to simulate yeah, sorry, you're not seeing this because I cut it off. But this is the div with 2 buttons is a child relationship, and then these 2 parallel are as a fragment because there's basically 2 top level divs in this example. And then I made my own code, made my own hydrate function and get next element, which is like what Solid uses, and a bunch of helper functions for the library. We can look at that in a minute. This is all, and I made a proxy for the element. This is also that at the end, you could create something that looks like a normal counter app that we've been looking at. And you could pretend this is what the compiled output is, which if you look at it is almost identical to the compiled output we've been looking at for Solid this whole time. But essentially count, set count. So there's 2 counters, count 1, count 2, 2 incrementers. And then this is the hydration output. So get next element for that template. And then so there's 2 counters. See at the end, I'll render it twice. Each one walks, attaches its click handler, called a render effect, which sets when you click on it, the set content call is basically like a helper, kind of like set attribute. I'm saying like this is like set child. It's just an approximation. What set content does, if you look here, is if it's hydrating, shortcut it. Otherwise, it sets the text content. So this is just like a helper that sets text content on an element, okay? But it shortcuts when it hydrates, because when you're hydrating, you don't need to set it. It's already been set. So it creates a render effect. And the funny thing is I'm actually using Solid's current. This example is not made with Solid 2.0. This is actually made with Solid 1.0. just for sake of being able to run it in the playground a lot easier. And then, yeah, we just, as I said, set the text. And you might be like, okay, well, the fact that these update independently and this works is no big deal. But what you have to understand that's missing in this example is we never render the actual DOM nodes. If I remove this template, this should still work. So like what I'm getting at is the rendering happens in my fake server setup here. This basically is calling get next element. So this is like our hydration thing. Now in the past, we'd look for hydration IDs and get the element off there and then link everything up. So what is this doing instead of getting hydration IDs? Well, what it's doing is if it's not hydrating, it just clones a template, which makes sense. But otherwise, it creates a proxy element. And what this proxy element does is, I mean, this is where the complication comes, but it actually intercepts append child calls, first child, and next sibling calls. And as it walks, it creates other proxy elements. So basically, this is a proxy of an element. We don't actually have the element yet. This is a proxy element. This is an element. Even us attaching this event handler to this element, if you look at the setter function here, it just creates an object where it, see, if you already have an element defined, it will update the element directly. But otherwise, it creates an object and sets the property on it so that at a later point, when it gets inserted, this is the key, when it gets inserted to the parent, and if it hasn't defined its own element, it basically calls the elements append child. And then node element this, sorry, if it doesn't have an element, it just calls the append child. But once it's been resolved, once it does have its own element, it uses the index of like where it is, like because at this point order doesn't matter anymore, to actually grab it out of the child nodes and match it back up. Now, this is incredibly complicated, and I'm not saying that this is a good approach. I just wanted to show that it was possible, at least, that we could literally create a proxy, build up our DOM here. At this point, even when we set up this render effect, these are not even real DOM elements. And then when they get attached, like in the hydrate call at the top, when we do the render, when they actually get attached and they call the, basically this would be an insert, but they call the append child, because this first element is actually, even though it's a proxy here because it needs to intercept, is actually defined, because when you call element here, it is like a real DOM element. Once it, at that point, it goes through, calls the append element call, which I show here. Where is it? Append element, and actually goes through and goes, oh, I do actually have, the element, or, or I don't, like, and basically realizes all the DOM nodes. This is just complete craziness, as I said, but it is interesting that we could take the almost exact same code Solid generates today and actually have no hydration IDs and basically match it up by letting it basically put itself in place, and then use the fact that, like, now that we have this tree of virtual elements, as we attach it to the parent, it should be the same tree in the parent, which means that we can just upgrade all these proxies to actual elements. Yeah, it's kind of, yeah, and it's invisible, yeah, because like these all look like normal DOM node calls. And once you've got your element, what you'll see is the proxy. If target element reflect blah blah, it just passes the stuff straight through afterwards. And any new element created after hydration won't actually create a proxy element. It'll create a real element, and so this only affects the elements that are there at initial render. And after, so there is an extra proxy through every element access, which would be expensive, for stuff that's initially rendered. So again, I don't know if this is a thing. I just wanted to see if there's a way that we could literally in place, like, generate code that works perfectly fine after the fact with real DOM elements, but at hydration time, temporarily basically run a proxy through it. Yes. Yes, as I'm saying, this would definitely be impactful to client performance. That's why I say there's no wins here. There's only trade-offs. So you make your SSR faster potentially, and arguably more stable because the difference here is the hydration mismatches aren't the hydration is based only on what gets inserted, right? If someone makes a bunch of proxy elements and then never attaches them, um, that's okay. One of the problems we've been having with Solid is people inadvertently don't realize that they're making wasteful elements, and they update the counter, and then they don't insert them, and then elements are and the DOM's only aware of the elements that are there. Like you can't hydrate something that wasn't inserted on the server that isn't part of the tree, right? So like this actually guards from that. Funnily enough, um, again, I'm not saying this is necessarily a good idea. I just wanted to prove that it was possible. Oh, sorry, reusing my client. Perhaps a question, but what's the benefit of having composability when there is scratching? No, no. I mean, composability is like one of the best properties we have as these frameworks. I mean, don't get me wrong. Maybe that isn't something that should be composable, but like you can expand out. Like Dev's already done this, like with like use socket or use like he's been building special server component esque. Uh, like we have use server, right? And which is like an RPC call, but he's been making specialized things that define the different export type. We have a whole stream about this. I think this expandability is a very, very, very good thing to treat everything as if it's first party. I think it's incredible. Will it leave more options in the ecosystem? Yeah, but like I love old React. I'm sorry, like that was my favorite part about React is that there was no single router solution. No this, like I know this is all about what I was talking about at the beginning. People want to eliminate the noise at the cost of what's good. This is like it's like like capitalism. Like it's this is like the idea that the hopefully solutions of the best qualities will survive over time. Survival of the fittest. You got to give people the ability to be able to make better solutions. Otherwise, you get stuck. Getting stuck is terrible. Yes, yes, and it's why people like Tanner and Tanstack are such huge fans of Solid. But I think the problem is it's nice in principle, but then when it gets to putting it down to actually doing the thing, it's actually really hard to accomplish because you have to make other compromises to be that general and generic. And at a certain point, you just want to get a nice solution out there, like RSCs or whatever, and have it just all work a certain way. And then it's like you have to, educate people and teach them like this is the right set of trade-offs. If there's danger of being too powerful, of like giving people too much power, right? There is a balance to be made here. So I get it. Um, I just think that we've been taking the power away too much for the last little while, and I don't know what to say. I think I like the idea of building a framework like Solid, which is like innately the most powerful, right? Like it just has the most capability, right? I mean, I don't know. Everyone has their own kind of preferences on these things, and I realize this is. I realize this actually because of my playing in Magic: The Gathering and people having different decks and different personalities and different like things that appeal to them about the game and metagaming and how they approach it. It's a very complicated system, and when I look at frameworks and people like that and like stuff like that, I see a very similarly complicated system. For those who are interested or want to know, just to give you perspective, as a Magic player, I play Gruul, unapologetically play Gruul, um, which is green red. That might mean something to some of you guys, but I make Gruul work in any format. People could be literally killing the mana dork every single game over and over again. I'll make that so it works to my advantage. Right. Um, so yeah. It's a value. It's about values. Don't know if I have any magically gathering people in the audience, but yeah. Yeah, yeah, and catering to the thing, pit of success. I'll hear about all the stuff of how we can onboard the greatest number of developers. What I think is interesting though is, are we going to a place where teams are getting larger or smaller? Right. Don't get me wrong. I don't think AI and these technologies are going to actually necessarily like reduce the number of developers we need. I think we need a lot of developers. I just think developers are going to be in smaller teams, are going to be able to capable of tasks more independently. And I think in those situations, and if you want efficiency and stuff, like I think this mentality makes sense, right? Like a lot of solutions for scale are because you have to solve the scale itself, micro front ends, like, so if you can alleviate that tension, then you can do more incredible things. Big mean green. Yeah. I mean, I'm a bit of a Timmy spike from that perspective, but yeah, big green's okay. I like aggressive mid range. I like mid range decks that look like they're mid range, but kill at aggro speeds. Basically, I like decks that are incredibly aggressive, but they don't fold to like a singular removal. Like every card is the most efficient possible in terms of like power level. Like it's not about ramping. Ramp's important for tempo, but not for size. It's not about landing the biggest threat. It's about at key points of time invalidating positioning by just having something that's so overwhelming that it has to be dealt with every turn, and then purely basically using virtual card advantage. Anyway, sorry. Again, magic chat. Maybe I'll do a magic stream sometime. Uh but yeah, I'm kind of a brute forcer, and I feel like maybe that reflects in my work on Solid. I force solutions into play. I have an idea of how to make things efficient, and then I force it into play. Yeah, I don't know. Anyway, let's keep on keeping. So why am I talking about this now? I was going to leave hydration until later, but there's a problem I'm realizing generating IDs. Consider something simple like this: div condition comp1 comp2. And for reference, this is what it generates in the client side for hydration, more or less. Get next element, insert something, memo condition, blah blah blah. And this is what it generates on the server: condition, escape, create component, right? So I've compressed it. I'm showing like, here's your div here, here's calling it create effect, essentially. Like here's your element, here's your memo, some components. Okay. Now let's consider the difference between Solid does today and what Solid could do in the future. Let's say the condition is derived from something async, like this, showing different components based on whether the user is an admin or not, right? Okay. Now, when I want you to notice that there are no reactive primitives in the SSR version. There's not even like a reactive wrapper because we don't care. Like if condition changes, we're going to just be re-rendering it all over again anyways. Where this version, there's like it's wrapped in a function, and there's a memo wrapping the condition to see if it's true. And you get what I'm saying? Yeah. Yeah. Oh, yeah. In terms of use servers, yeah, yeah. And to be fair, these are values that I shared originally with React. I think it's just a very, very important capability. I don't like my hands being tied. This is the thing you have to understand is when I sometimes wonder. I'm older. I don't than a lot of the people who actually slightly older than a lot of people who actually build frameworks. I I got in this game late. I was already like 35 when I started building Solid. Um, I guess no, I guess that's not true. I started building Solid when I was 32. I open sourced it when I was 35. But um, like a lot of people, I'm not all of people's journeys are the same, but a lot of people got into the framework building stuff. I feel like at a younger age, they were really smart kids out of college, and then they got hired by a large company, and then after a few years of doing stuff, they get to about the 5-year mark and they're about prime for it. So we're talking about like 26, 27 year olds generally being like the core age of like big movements on these frameworks. And Um, for me, like this is like 32 to 35-year-old me making decisions. So my perspective of what I was trying to accomplish was, very, very different. So yeah, I don't know. Yeah, I think it reflects in this. But okay, let's continue on here. Okay. So now I want you to notice there's no reference. Did I share this document yet? If I haven't, I should. Solid today doesn't even bother wrapping the conditions, the function because it needs to render independently. In solid, we re-render components on the server as a suspense result. So even if the state condition changes, it doesn't matter. Still, we do need it stable for async between runs. So if there's a new create resource, we can pick up the already created promise. It's possible to rerun the suspense to rerun the component that creates a resource. So this is why we use hierarchical IDs. Okay, so in the same location. So while imperfect, it actually works pretty well using components as our nested level. Like show component is fixed regardless of what path goes. So it registers as one and the next sibling can be two. What I mean is in this, like if we had a show component here, for example, like instead of this ternary, I'm using ternary on purpose, but you could see that no matter if component one or component two got chosen, the show component means that any sibling after the show, like show could be one and then the component after could be two. Like any component after it would keep treat regardless of which way, because this would be 1-1 and actually they'd both be 1-1 depending on which way it went, essentially, because we're nesting at the show component level. However, if a conditional is a ternary like above, it might mess with things if the number of elements it returns differs. That this would impact siblings. Luckily, people generally aren't fetching resources really deep under a ton of conditionals in their apps. If those conditionals change, you would expect stuff under them to be thrown away and refetched anyways. And mechanisms like query caches give us, existing promises other ways other than using the serialization ID. But what I'm getting at here is Solid's current approach, which is basically at every component nest a level and then use a counter, actually has a bunch of edge cases. People just rarely hit them. I think it would be clear looking at this, if we want a solution that can handle fine-grained polling, like separate things, it has to be finer than components. So what? Well, the ownership graph of reactivity works pretty well because it's where all the decisions happen. It would be much deeper than components, but we aren't serializing one place. Maybe it doesn't matter. And actually, I've been testing it. It isn't actually that much deeper than components. A lot of times people have more components in between than they have decision points in the tree. I'm actually finding that the hydration IDs are actually shorter. I actually implemented this ID system in the latest builds. You have to pass it to the owner, but it's really fun for debugging to have every node have an ID. So you can be like, oh, it's 001 that updates. Like, oh, what's a dependency? It's on 002. Like, I know that's kind of weird, but actually, like, we already had naming for convenience for specific nodes for debug, but now we could turn it on so like every node has a number. Anyways, where am I going? More so, if we were ever to serialize our reactive graph, this would be part of it. Like if every node had an ID, then the rest would be pretty easy. This would unlock things like resumability and easy serialization of any computation we felt was too expensive to run on client-side hydration. Yeah, so here's the thing. Resumability uses like a very crazy compilers anyway, so maybe it doesn't matter. So it injects all the call side IDs and uniqueness like I talked about. But technically speaking, with this mechanism, we can basically, because every node has an ID, then we can be like, okay, this node value is X and it depends on this node and this node, which means when we go to hydrate, we don't need to rerun the node on the client. We actually know the dependencies so that when that node like registers, it can like link up the thing without running any of the component functions because we have the value. And then we go, like, okay, I depend on this. Well, let me add my node to the other node. Like you can build the graph back up without actually running any of the user code. However, we have a new problem. The graphs have more or less to be identical on both sides. And you can see from above, they aren't, right? Because if you have ownership, if you look, I mean, I drew it again. This memo is now adding a new ownership. Like this inserts a new ownership and we had no ownership. Right off the bat, there's an insert which creates a render effect. And there's an additional memo, which around a condition, which we don't need either on the server. The render effect would cause an additional nesting level and the memo would offset the counter used for other components. Even if we added those, what about this template? Disabled. What I'm showing here is that the order, like we group effects together. so the order they appear in the HTML is not always the order that they appear on the client. What I'm going to show here is we actually do the insert before we group all the attributes together. And then we have a separate effect for the value, because we treat the value property on an input special, and it runs afterwards. This is and it's handled separately. There's a very good reason for this. It has to do with like ranges on like certain types of inputs, and like I'm just saying there's a bunch of rules, okay, because of the shape of the DOM. So the first expression is the first value of the H1 getting inserted. The second is the attributes on both, and then the last one is the value. These are way out of order, but intentional, so that we can set the value last, and even elements like options, that's another good example. And we do it independently, so it doesn't need equality checks. Other property attributes are grouped, and we handle inserts separately. Whereas in SSR, we generate this with wrapping expressions and functions, right? And you can see that the order is not the same at all. Like we actually smartly put the value and disable together, so we didn't need as many template strings. We actually just added them. So like we actually try and put as much static parts together as we can in the template, and then group all the holes the best we can. This grouping is by order and not by behavior. How would these be done efficiently with the same shape? Maybe something like this. So this is what I was talking about, creating a new compiler, which basically reasserts the client ordering, where we have the insert first, the attributes, and then the value setting, and then creates them in this order, and then inserts them in the template at the end, back in the visual order. Because again, you're creating a string, so it's you have to get them back in order at the end to actually output it. Each resolve would create a new owner in that order and attempt to flatten their expressions. If they hit something async, then return not ready, the SSR knows how to handle it and creates the return template object, like we showed before, the whole pulling thing in the last write-up. Honestly, I don't know if performance would be that much worse, but I suppose it's worth a shot. It is interesting that, in a sense, SSR render would be able to group things almost identical to the client universal renders, and it would just be the final output that would be different. That being said, is server becomes even more dangerous here, because previously it only really messed with resources. You know, like if you didn't have the count be the same, like if you tried to create like a signal only under a used server, but now it can't wrap any reactive statement unless you know you're creating the same on both sides. Yeah, we see that we can see that you want. Does the spell playground actually show? It shows no. It shows the. I mean, I can't tell. I mean, it shows the. I don't. It shows the output code, but I don't think it shows the output result. Like in solid playground, I've been using this the whole stream. We're showing here we have the same switch: client side rendering, server side, client side retention. We show the output code. Yeah. Yeah, I don't know if you ever noticed that one before. Is that what you meant? Like, this is what I've been using on the stream here. We actually even show the universal thing. This shows like what it works when it like if you use it with 3D with 3 fiber or like terminal or whatever. You have the universal output as well. Yeah, I mean these all have overhead, right? I actually think the IDs are one of the more compressed way of doing this mapping, because it's a hierarchical problem, right? So I the problem is, like, I tried to currently, so we do at component level, we introduce this, but then as it's mentioned here, the component level is imperfect. The only thing that is actually perfect is if you match up on the reactive graph, but then the client and server have to basically resemble each other in terms of graph shape. I missed this one. So server render. Generate. It's funny. The option to call it generate was something I actually got from Svelte too. I mean, you don't see it here, but the option actually in yeah, because let's look at Svelte. We've been looking at server. The client version is on click handler, set template effect. See, the render effects called template effects, pend anchor. Yeah, okay. Looks good. Anyway, but I'm just continuing on with this. Oh, do you know why the increment? I was trying to wrap my head around the basic counter example, why the increment shows unused on the server installs playground. Because this is because it's smart. Um, because you can't click it on the server, right? So the server results don't need to add a click handler. So because you can't click it on the server. So technically a smart tree shaker can also remove this function altogether because essentially there's no click event to register. Sorry, just a second. Might have missed a call. I don't check this on stream, but no, doesn't look like anything. Okay, cool. So anyway, yeah, where was I? Yeah. No, the derail's fine. Where was I? Each resolve would call the owner, blah, blah. Honestly, I don't know if performance, yeah, okay, where we were. So back to the beginning, if we want to keep hydration IDs for serialization, case one, and remove them for template matching, there's a potential for solution here. It just perhaps less performant on both sides. We sacrifice hydration performance for removing serialization costs hydration IDs, and we sacrifice server rendering performance to get better stable IDs. I would say both solutions are probably more sound than their predecessors. Just funny that they're almost nulling out all the other, each one's like nulling out the other's performance. One makes SSR slower, one makes what makes SSR slower to be more accurate, and the other one makes hydration slower to make SSR faster. Do you know what I mean? So it's like, but like anything else, we don't know until we test it. Anyways, yeah, it's one of those things where like I think the solution is probably better, but it's like, is there a performance hit here? And don't get me wrong, I've been lamenting this performance hit. To my best of my knowledge, it's still like 3 times faster than React. So like at least the hydration one might be worse, but the server rendering ending these things is still faster than like all the VDOMs. It's just like, is it slower than Solid today? Yes. Is it slower than Svelte today? I think so, slightly. Right. Solid still like, so like this switching to this would definitely be a hit, but it would open up, it'd be better. So I don't know. We'll see. Anyways, this is where I've been working. As I said, I made a compiler. I've been working on a compiler for this new output, and this is kind of like the basis of what I wanted to talk about today in terms of SSR. So before we go on to a couple other topics, I thought maybe I'd show off actually, you know what? Maybe is a good time to go on to a couple other topics. I don't know if I'm going to do this week in JavaScript in the typical sense, because I told you most of JavaScript conversation and this week stuff has not been particularly interesting to me. But there's been some proposals or new work in other frameworks that I think we should talk about. Is having unique node IDs continued on this new hydration mechanism? Because it seems like those would. No. What I was trying to say is the IDs are needed for serialization regardless. Or for like of resources and stable IDs and all that kind of stuff. So we're creating the IDs anyways, and I've actually created the mechanism in solid signals right now. Solid signals, and you can turn it on by whether you put in the root, but the gist of it here is one of the things I did when I was working on it is I actually built a pull-based reactive system inside Solid. People know that classically, when you import create signal on the client, it's the normal one, and when you port it on the server, it's like this not reactive one. Well, I've actually been building a pull-based system, and the interesting part is even the ones that are like the non-reactive pull-based system, they use the same ownership model from Solid Signal. So you actually see us sharing more code, and that means that like class owner here has an ID which can be set, and then if it's set, when it basically and it's the current owner, when a child's created that doesn't have an ID set, it actually has this get next child ID function, which is actually calls this format ID based on the current parent ID and the current child count. And if we look at here, the format ID is actually very similar to what I've been doing in Solid 1.0. It basically uses base 36 to string to convert the numbers. So instead of each digit only having 9 characters, you can go up to 36 characters. And then if the length is longer than 1, we add a delimiter character from the capital character case sets, because these are all lowercase. So basically it goes 0 to Z. And then because we get to reuse the same ID generation and stuff, I'm actually kind of, I'll show it off. I think this is actually kind of cool, which is not true about Solid previously. But if I go to the next branch and look at packages, where is it? Solid source server. If you look at the, there's a signals file, which is basically filling in like the signals library. What you'll see here is that the code is generally a bit different, though we do have like create memos and stuff, but it's using its create memo. Let's see, where's its create memo. It actually looks a lot like the internals of the signals library, because it's actually using owner and get owner and run with owner. All the owner APIs are actually the same as the client side ones. So if someone does want to have reactivity on the server, they could import directly from Solid.js signals and have the non-reactive and the reactive versions working together in the same cleanup and ownership model, because it's literally the same base. Reactive systems are really 3 parts. And I talked about this in a previous stream. It's very cool to see this happening thing, because like with the pull-based system, we don't need the advanced scheduler. When we don't need the auto tracking, but we need the ownership model. So we're using the ownership model. But all 3 parts are kind of quintessential into how React systems are getting built today. There's now like an ownership model, that's the baseline primitive, that the dependency tracking gets basically inherits from. And then when you add effects on top of that system, that's how you add the scheduling in. So yeah, the amount of shared code is actually increasing to the point that, other than the signals implementation, it's theoretically possible the rest of the Solid doesn't have to differentiate from client and server, as long as it's like optimal enough. See, part of me wants to do stuff like, and I guess it's a part of the signals implementation, but like mapping, for example, is a place where we can do much more optimal stuff on the server, knowing that it's running once. So like I don't necessarily want to use the client side one, but beyond that, once you kind of go out and compose on these primitives, since they use all the same primitives and there's an equivalent version on both sides, like the code doesn't need to be any different anyway. But where I was getting at is that, yes, the IDs are important for a bunch of features. It was the cost of the serialization. So we can continue to serialize the IDs in the template, or we can do that virtual hydration proxy thing I was talking about. The challenge, as I said, is the pull-based reactivity. The thing that I didn't write in this is that I need I can't keep on using the component-based approach. Like I can't just throw this away and use component-based IDs with the current model, because of lazy evaluation. Basically, when we knew that memos always acted eagerly, when you went create component memo inside, you knew not only that it was created under that scope, but it actually ran first under that scope, which means that it would inherit the ID. So you could do something in the component that's like, it's in Solid's current code, where it's like set hydration context, run the component, set parent hydration context. Like you could basically just wrap it synchronously, and you know that the code would have run in between. But now, because it's lazy, it doesn't run until it gets inserted, which means that component style wrappers don't work, which is why even if we're using a rerun model, we still need to basically inject the ownership context into the tree, which has a performance cost. So we're kind of stuck regardless. I didn't bring that up here, but this is why, this was the end of what I was trying to say here when I was talking on Twitter. This is why I can't wait till later. Because essentially we're kind of, because of the other design decisions on the client side, we're basically we just have to move forward with this direction. And we want those things. Like this is again, this is all a matter of scale. I can be disappointed right now until I find the solution, but it's not like we're talking about a bad solution here. It's not only better, it's still more performant than the most popular solution. So it's like, what am I complaining about? I'm just very picky. So anyway. Yeah, let's continue here. Okay. So yeah, let's go to Twitter. I think the first thing I want to talk about today, no, not the notifications, is sorry, bookmarks, not AI. That's not the first thing I want to. I'll talk about this blog, React Labs, View Transition Activities, and more. I don't know if you saw this. This is actually really cool stuff. I've been really enjoying the stuff that React Labs has been putting out, and I think we should look at it. Don't worry, guys. I will do Svelte next. I should have enough time. But yeah, I think this is interesting because they're basically proposing 2 experimental features: view transitions and activities. And if you haven't seen this, it's worth a read because it's a different take. This is a very incorporated take. It's funny when I looked at view transitions integration in Astro, it was like very incorporated. It was just like, here are tags, just everything works. Then at SvelteKit did the other approach, which honestly I admit I would have gone that way too, which was like, just give the hook to the end user and let them do whatever the hell they want. So basically, as long as you time it right, so that when you're rendering, that you get it right before you like commit your effects, then the end user can do anything, and it's very, very, very powerful. So again, a very powerful API. React has chosen to do more like Astro's approach, actually, but considering all the other asynchronous they have. So it's actually very complicated, but very powerful if it works right. So I'm going to admit view transitions are not what I'm most interested about in this blog post, but I think it's worth looking at here, because what their idea here is, okay, what to opt into animating an element, rapid and new view transition component. Okay, cool. This new component lets you declaratively define what to animate when the animation is activated. You can define when to animate by using one of these 3 triggers in view transitions: start transition, use deferred value, suspense fallback. Okay, this is an interesting one for me. It's that I don't know, like, this easy to understand. You're just wrapping something view transition. This is always tricky because, I mean, suspense is easy to understand. It has a fallback and you do it. But these two are interesting to me, and I'm going to be interested to see how much the general React audience knows how to or when to use these. This article is not aimed at the general React audience, to be fair, but more advanced users definitely. But like, start transition starts a transition. But again, I don't think most people think of starting their state transfers as transitions. Luckily, this is built into most routers. Like, most routing should be a transition, and you probably will never touch it yourself otherwise. This one's interesting because this is use deferred value is like latest. We have something similar in Solid, and it's something that you actually need more often, but you kind of have to be aware of what's going on first to do it. So most people don't even realize they need to use it. So this has actually been a big part of my Async 2.0 journey, is figuring out how to like make this stuff make sense. And we'll talk about that more when we talk about the Svelte stuff. But these being the triggers is interesting. On one hand, it means that routing should get view transitions by default because it will be built in and then people just put it in. So that's a win. And that's probably the biggest win. We can pretend that no one will ever use this, even though they probably should. And then this, some people will put this in sometimes and it will probably work. So I think it's interesting trying to just like understand the implications of everything. So let's continue. By default, these use CSS, blah, blah, blah. The other reason I'm interested in this API is because Solid and React classically have not have built-in transitions, unlike Svelte, which does. So having like, we have like transition groups. Vue has that first party. React used to have it first party and then kind of shifted out. Solid has one that I built in an afternoon looking at Vue and probably haven't touched in like 7 years. So, and there's also like Motion one, and we have like third party ones that are actually good. But I'm just saying, like, as a base level, it's interesting from a core primitive, being able to bring this back in. Yeah, so there'll be some libraries that will build transitions in. I'm just saying, you as developer, it's hard to picture you ever using that API. If you're familiar with Browser's View Transition, whenever he supports it, blah blah blah. I don't care too much, but let's see here. When we click into it, is this without it? Yeah, maybe this is the without it version, right? They just show some examples. Okay, let's just use router conditional, blah blah blah. Use meant to use navigation, animating, right? Navigate. Yeah, they're showing it built into the router. This makes sense. And then, yeah, okay, I think I saw that one this time. You guys probably can't see it, but it's actually fading. View transition, wrapping it. Okay, yeah, so they're showing you how you use it. That makes sense. So that seems simple. I like it. Seems like a win. You can opt out. Makes sense. Default none. Customizing animations by default usage includes crossfade. That's nice. I think this is a win. Like it seems very simplistic way of doing it. Shared element transitions. You give it a name. Is there an example for this one? I'm kind of interested. Oh, that's cool. You see, I mean, it's probably coming in small, but the way it fades in on the same thing. I think this is a win. I think everybody it's always interesting when you see stuff like, but if you picture that all your anchor tags are going to have this already basically start transition built in, you can start to see how this actually works out. This is a very smart system. I think the thing was, when I first looked at this article, I was just like, what? Yeah, okay, you can add cause, navigation forward, nav back. This feels like it's an instruction manual for people building routers, which is good. This is actually the people who need to actually pay attention to this. Although you will have to express this to the end user, how to, like, hey, if you want your view transition to only happen forward or backwards, make sure to put share nav forward on and put your class. But I think that's okay. Yeah. Animating suspense boundaries. So we'll activate view transition to animate, fall back to content. We can suspense with the view transition. Yeah, so you put it outside. So this looks like old transition group, I'm gathering. And then, so yeah, so that you can't see it very well but this fades in on the fallback. And then if you put it inside the fallback, you also have a separate slide out one, right? Okay. Yeah, they faded in and faded out. It's hard to see in this example here. You probably want to, if I didn't share this already, I did. You probably want to look at this yourself. Animating lists, put one on each key. Yeah, this is pretty cool. I think this is one of the coolest things I've seen in a while, actually, out of the React stuff. This is actually, it's like, I guess, finally a version of transition group that they like. This is very cool, and it helped. I think there's been a lot of criticism about React not paying attention to the client. This is a client only kind of feature. This is actually really good. Yeah, because when I first saw the API, I was very much on the Svelte kit side of things, where I was like, I can just put an await around start transition, and then ta-da, I've given people that hook, right? But kids, like, let's face it, the audience for this is mostly like the router, but they did the same thing they did with suspense, which is smart. No one needs to write transitions or use deferred value probably, but everyone just writes the transition component like they do suspense in their code. So this is all you really need. This kind of inversion of like having the one API hidden and then having the other API just kind of work is really good if all the libraries participate in this, right? If you can encourage their libraries to do the right stuff, then people will get this benefit out of the box, and it's a sensible behavior. I like it. That's very cool. Activity. In the past, we shared where we're searching API to allow components to be visually hidden and deprioritized, preserving UI state and reduce performance costs relative to mounting or hiding with CSS. Now we're ready to share the API and how it works. So now you can start testing in experimental React versions. Activity, the new component to hide and show parts of the UI. When this activity is visible, it's rendered as normal. When the activity is hidden, it's unmounted, but will save its state. You can use blah, blah, blah. Don't mount when the activity is hidden. Yeah, so this is off screen. I think yeah, I mean, you can just wrap each one in an activity. The name activity is weird to me, but that's fine. I guess it's better than off screen because it can be on screen or off screen. But yeah, so they wrap each one, and then basically if you wrap each one, then each one would get, it's almost like they're both there, but they're not like completely live when they're off screen. Pre-rendering with activity. Yeah, like basically because you are loading all of these if you do that. So I saw some people respond to this and talk about how this is awesome for routing. The truth of the matter is there's two different types of control flows when we come to conditionals. There's show, this is show or suspense, and then there's like, or I mean, you can argue this is switch match, and then there's like dynamic, like our dynamic component where you're just swapping one thing. Routers are usually dynamic. They don't. By default, routers aren't like if this show this, if this show this, if this, because the list is dynamic. So literally, it's more like match on URL render components. So they don't flatten out like this to do preloading. It'd be interesting if on a per route section hierarchy level, you ask the question, but usually like you don't know 1 or 2 or 3 or 15 or 100. So you're generally not doing this. Like for a fixed set of tabs, you are doing this, but you're not doing this for most things. I actually think transitions are a better API generally for routing than this. This is good for like tabs. Yeah, keep alive. The activity, visible, feature modes. Yeah, hidden. I think it's interesting. I was so interested in this after reading the blog post. I re-implemented it in Solid 2.0 demo. Let me see if I have that here. I didn't call it activity. I already had this. I just tried this hidden and visible thing that they're doing. Because essentially, I called it boundary because technically suspense is a boundary, error is a boundary. This is a different kind of boundary. It has the same idea of scheduling, right? Because what this boundary is saying is like when it's when it's bigger than 2 or smaller than 5, it's hidden. Otherwise, it's visible. So when it's visible and it's reading something async, when we load, it's loading because it triggers suspense because it's visible. And then when there's like a 1 second delay on this async. And then when it gets bigger than 2, it disappears. And then when it gets 5, it comes back again. I guess the problem with this is it's really hard to show when rendering actually happens, right? Because if I go in here and console log in here, we're going to see it because it's on the pure side. This value will update while it's off screen, but it won't update the detached text node because the effects are held, but the reactivity system is still present. So I don't actually have a good example of this actually in action now that I think about it. But yeah, I just made boundary component under suspense. I guess like if we said it was hidden until it's 5, this is an interesting one because if it's off screen initially, it's like, did I break this? And we found our first bug. Lovely. Because in theory, that's funny. I tested this in the solid playground without the final component, and I thought I had this nailed. Because basically what I'm saying is if C is smaller than 5, it's hidden, which should mean that suspense doesn't trigger, but I wonder if I've actually killed this whole thing. This is the fun part about, okay, no, I haven't. Yeah, because I'm going to have to look into this. Before I had the exact same demo, but done purely with in the playground with like no compiler. So it's like, okay, loading, and then I put a counter that increments. Disappears, come back. But when I did it and I removed this, at least in this version of the code, oh no, that's funny. I broke it. Anyways, not important. What 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 you see here is in the what I wanted to show that you can see in this demo is creating div happens initially, and then even like when we reinsert it, it doesn't create the div again. See, it's back. It doesn't like this console log create div only happens initially. So I'm showing the alive one, alive two is inside the effect. When it's off screen, it's not firing the the effect. So this kind of is the proof of concept. It seems that I have a bug forwarding suspense that I introduced at some point that I'll have to look at. But um, what should be happening in this scenario is when it's off screen initially, it doesn't actually trigger suspense. I guess the reason this triggers suspense is because it's doing the read up here, which means they're both triggering suspense. Like if I didn't want this to trigger suspense, I would have to do something like this: if count like this. Then if I did this, see the timing here is going to be interesting because it's going to disappear now immediately, not when it finishes loading, which is fine. So when this goes to 5, it's going to show even 4 before it loads. But with this scenario, if I remove the count is bigger than 2 and it starts initially hidden where it doesn't trigger suspense, you saw that it loads immediately, and then now it should show up in theory. But oh no, it has to get up to 5. Sorry, my bad. Now it shows up. I clicked it too fast, but you can kind of see that. You notice how like when we clicked it here too fast, you could actually see the previous value here. It's interesting because it's because technically it's still live off screen, but it's not updating the DOM. Like the reason it showed 2 was because that was the last. No, actually, no, that's interesting. Why did it update 2? That's actually an interesting question. It must have at the time. No, it is at the time that it goes to show it. It renders the DOM with the value that's currently there. Which at that time happened to be 2. It actually didn't render it off screen as we already showed here. So this is an interesting thing, the interplay between this and async with tearing. But aside, okay, it was fun. Render effects run at least once when they are part of the active graph. And yes, they do run at least once. Yeah. Yeah. It's funny because Magic has its own vernacular, right? Like just like programming does. Okay. Anyways, in general, I think we're going to see a lot more of these things. Just understanding like let me see. If I go in the signals package, I actually did a lot of work here under what I call boundaries. And what you'll see is, funnily enough, I have all the different kind of boundaries here, but create suspense. It creates what I call a collection boundary. Create error boundary also creates a collection boundary. And then this is what create collection boundary. And then this one here, create boundary creates create bound create. Well, if I spent the time to go through this, a lot of the code is almost identical. It's the exact same patterns for creating all of these types of primitives: suspense, errors, off screen, or whatever you want to call it. They actually use the same mechanism of producing their own effects queue to hold effects, and then create their own, what I call it, I don't know what they call it. It's a boundary computation, which is designed in such a way that it both can collect all the nodes underneath it, and it also any top level throw or whatever it can grab to. It basically isolates the change. And the reason this is important for stuff like off screen is because when off screen is off screen, it still has to handle async. It still needs to like know not to leak it up or whatever. So while my demo didn't work quite the way I was hoping to in that example, and I have to look into what the bug is, generally speaking, these are all actually the same thing. They're a mechanism for isolating an execution and then managing an effects queue mechanically. So it's really interesting to think of like how many different applications. I actually came up with an application that I thought would be really cool, that I ended up throwing away. But it's going to be relevant to our next topic, which is that, one of these applications that I was thinking about, was what if we create a control flow that looked like this: transition, right? And this isn't a view transition, to be clear, but that's a transition when route.url and then URL is pending. Okay. Because I'm always looking at getting rid of use transition. I've been looking at getting rid of use transition for ages because, as I said, no one really knows when to use it. And I was like, what if we could like do something like this? So you could like draw your route and then like, you could put like some style, like, my favorite, what's it? Opacity is pending 0.5, otherwise 1. Let's format this. Turn off the, make this in a way that I can actually see it clearer. I've clearly broken the formatting here at the moment because there's errors on the page. But the idea is you could like have some route component. I don't know, that's like based on the URL. And as long as this was keyed, right? As long as this was keyed to the URL, so basically whenever this URL changed, it re-rendered these children. You could basically very easily render the have the current, like, first initially, you hit something async and it suspends whatever. But like after the fact, when you change the URL, what you could do is you could basically keep this here, and then you could render again keyed with this new URL. Notice it's not a function. And then until it resolves async, have this be active with this is pending signal set to true. And then once all the async resolves on the forked branch, swap in its content and run its effects and do everything. Like, it's very easy with the primitives I just showed to build something like this. And you're like, oh, done. No use transition, so to speak. And you now have like preloading. So like when someone, not just preloading routes on hover, but like literally like transition without transitions, right? Forking, very, very simple forking here, because you can just use this as a keyed fork. The problem is two things. Obviously this route URL would update before like the things, so you have that problem, the tab moving early. Of course, you can just like, you could do something like, this could be like future URL, and then you could do something like on complete. So like whenever it finishes the async and does the swap, you can do something like value. You can like pass back in the value again, and then be like, look, you can go set URL now to the value. So you could like basically do something where it's like predictive. So then your UI stays outside on the old URL, and then once it's ready, you can update it to the current URL. And because this is keyed again, there's this detachment, because if a future URL changes in the future, it's not going to change this up. It's keyed to that. The problem, because this basically works and it'd be easy to make in user land, even relatively easy. The biggest problem with this is, what if like you don't want it to be keyed? What if when the ID params change, but like the query params you want to be able to change without re-rendering the whole page? Well, then things get awkward. Like, sure, you can inject them from above, but when the future URL changes and the query params at the same time, the current reality will see that. So this very naive approach is simple, and it's honestly what Solid did in I forget what version we added transitions for real, 1.2, But like back in like early 2019, we basically added transition properties to our show components and basically worked like this. But this is better. It controls the scheduling of effects. Could do this kind of boundary. But honestly, I think React's right about use transition. Okay, cool. That's perfect segue into the Svelte conversation. Yeah, I don't get persist. I don't get activity either. Persist is better. I mean, the thing is, you have to look at. There's more things that you can do than today. I didn't finish the React blog, but like they were saying that like maybe we'll do it for like saying client only or you know, etc. The rest of this blog is. Oh, actually, there's one more thing before this whole conversation. They're looking at automating effect dependencies, which is funny because I'm at a point where I'm like, we need to separate them out. Right now, with the React compiler, you have to set your effect dependencies directly. These guys are talking about setting before, like using the compiler to figure out effect dependency. The funny thing about this is we know it's imperfect. So yeah, effects can be hard. Unfortunately, some hooks still think in terms of effects to life cycles. We found often confusion for effects you don't need. You might not need effects. Agreed. Blah blah blah. Most people don't need effects without dependency. I think it's better. Yeah. Do you know why this works? Basically, React doesn't care because if the compiler screws up on the effect dependency thing, it can always like default to like always running the effect every time. So like with this code, confer dependencies for you and insert them automatically so you don't need to write them. With extensions like ID extension and use like you can provide a code lens to show you what the compiler inserts for times you need to debug or optimize by removing a dependency. This helps reinforce the correct meta model for writing effects, which can run anytime. So like they're framing this more as like an engine you can tweak in terms of like figuring out what dependencies. But you have to understand the default means that if you tell people they don't need to write dependencies, they're just not going to write dependencies until they find that something is either doesn't work or they don't find that their effect just runs over and over and over and over again. It seems very dangerous, but it will be interesting to see. Maybe people's developer flows are different enough that they're like always sitting there and like using these built-in IDE tools to like analyze how efficient their code is. Maybe that's something everyone does. So maybe this will work. Oh yeah, compiler ID extension, fragment refs, yeah, gesture animations, current stores. This is a big thing, possibly for like the tan stack type people in third-party libraries. Anyways, it's enough for this right now. I think those are the big headlines. It's just interesting because like compiled effects are hard. Like Svelte moved away from it. Their effects are runtime now. The compiling the dependencies doesn't allow any level of composition. Yeah, this is interesting. Yeah. I mean, you can ask questions whenever you want and interrupt me. It's all good. And I will probably answer you. But I am short on time, so I'm just gonna blow through forward. But if something comes across and I feel like answering it, I will answer at any point. Okay, let's continue. Hopefully everyone, I think a lot of you have seen this. Asynchronous Svelte. You can now use the wait keyword in Svelte in your script inside derived expression, blah, blah, blah. Okay, by adding experimental async, sounds good. Let's try things async playground. You will find bugs. Yeah, right. Background. If you did it on mount or in a wait block. Yeah, this works, but it's quite verbose and offers no coordination. If two components are both fetching, they will likely have independent managed error loading states, often resulting in janky UI multiple spinners. Yes, because it's not because no inversion of control. Like basically, this is what I was talking about before. Is like you can't combine them. One of the benefits of the inversion control suspense is that you could have like multiple different async sources and be like, no, they're part of the same block or the same conceptual thing. Whereas like await, you have to pass the promise to it, and that's that. You could hoist it up, but then you'd be awaiting the like your promise all basically at that block level and then passing all the individual values all the way down through. So like, yes. Brands like Svelte could remix offer an alternative. Instead of fetching inside the components, we do your async work outside the components. For example, in a load function, this typically results in better user experience, blah, blah, blah. But it too has a problem, prop drilling, blah, blah, blah. All the stuff I just talked about, core screen validation. Yeah. This is all why we didn't design solid that way. In recent years, component frameworks explored a third way of putting things in. right? Suspense and transition. I guess it is recent years. We released our first version of suspense with transitions back in 2019. So that's end of 2019, I think. Anyway, solid has great reserve suspense transition as well. Vue has a wait inside script setup. But we said sooner better renounced and future objects and existing approaches. Yeah, minimal ceremony, want to write code, wait, flexibility, blah blah blah. Parallel by default. Trying to safely seem to be pure things in sequence. Yeah, this is an interesting one. If we or overlapping, performance. Await is a very what's really cool about await is the consumer has to put it out there. You don't have await, as I said, as a key, it doesn't it composes by coloration. So like you can trust it at the top level. It doesn't matter. You don't have to search deep for await. Do you know what I mean? Like you know that if it's async, it's going to be like right there at the consumption point, which works quite well because you don't have all the other. You don't care what happens inside the thing you await, which makes it really good for the compiler target. Actually, I remember I was sitting at React San Francisco, whatever the last one there. I think it was 2022, was it, or was it 23? With Theo at the dinner before the conference, where me, Tanner, and Ben from Astro were really harsh on server components, and Theo was telling me how much he really liked the new async components in React server components, and I was like, isn't it weird? Yeah, but the thing that he pointed out to me, like because like it's blocking conceptually async, but what he pointed out to me was that where is this? This is review routing for future reactivity designs. Yeah, this is very old. He pointed out to me that like people don't really care, they just want to await. So like I basically was trying to design create async, and I was like, oh, okay, it could be memos returning stuff. Where was I? Concept layer. No, I already skipped past it. Where is it? Oh, was it not this one? Let me see. Just a second. Sorry. Let me see if I can find it. Maybe it was this one. Huh. Maybe it's not. Oh, I thought it was this one. I was trying to. Oh yeah, it's right here. I was like, wouldn't it be cool? Trying to appease to Theo. I'm like, wouldn't it be cool that we have all these async stuff, and this is before I had create async. I thought it was like memo but eager. If you could just have them all, do this, and then just write await in your code, and then it actually convert it into a bunch of these calls and be non-blocking, because we don't have to like trace for async. You can just know that 100% if you see an await, like you're free to basically wrap it in a create async call, which is a really cool compiler aspect of async await that is not true of so many other compiler hooks. Like this is one you can depend on. You don't have to worry like, is it a component, is it not a component, is it a function or whatever. Async is actually really easy to analyze and consistently do the right thing for it. So here's a wait pool will be visible, overlapping updates. Okay, sorry, it was just something I was thinking about it. Design in that nutshell. You can now use await in 3 places: top level component, derived expressions, or a template expression. We also use pending snippet to the smelt boundary, blah blah blah. Inside derived. Okay, to know if updated currently affect pending. Yeah. Does that make sense? Is pending basically, although it's more of it's scope injected as pending. It's not like asking which async is pending. Like, is this user pending? It's going, is this scope pending? Use case, most obvious use case would be loading, simple fetch. Yeah, and obviously you can trigger other resources, avoided waterfalls. Right, because these awaits are all separate reactive scopes. This is very similar to, yeah, it's an interesting one, right? You can inline it here, which is kind of nice, right? Because essentially without the compiler, you have to basically hoist out the fetching and then read the signal in here. where the compiler can just go like, oh, we can inline this, right? This is doing basically the same thing where this doesn't block this, doesn't block this. If you guys remember, I did on my async stream a bunch of demos where we could show basically that like with signals, there's no reason because each thing gets wrapped in its own effect, right? That there's no reason to not do it. Actually, I think I have this right here. Is this the right one? No, this is the nested fetching one. This is showing how you can fetch in a component, in a child, all the way down, and that they don't block. So like, see, they all start at 0 and they all end at 2. So basically, you can put a component in a component and have them all fetch. And because they're not, because essentially this has nothing to do with this, a separate expression, they can all independently not waterfall. Sorry, this is not the example I was looking for. It's a cool example. Let's see if I can find the example I was looking for. Projects. Parallel fetching. There it is. This is the one. Yeah, where you can put like comp A, comp B, comp C, and they can all fetch their own data. I mean, this could also be inline. Like I didn't need to make these components. I could have just like put the fetching up here and done them separately. And they again, 0 to 2, they don't block each other. So yeah, this is a very good quality of these sort of solutions because technically they're using signals under the hood. There's some key differences. We're going to get to it, but the baseline is you can see it kind of similar because they don't throw. My understanding, not all work can be parallelized. Any await expression inside the script run before expressing the template, and then the sequence would you be expect. Though if X is subsequent updates, yes, right. Yeah, yes, you need necessary. Yeah, there's no way to avoid waterfalls when X is async. I think is X async in this example? Yeah. If there's a direct data dependency, you can't avoid waterfalls. That's fine. Okay. Necessary waterfalls. You wrote a whole thing here. Yeah, artist. Yeah, like these are not avoidable. It's better to both fetch on the server near your database, so you combine them into a single thing. Agreed. Let's say, or use server components. Blah blah blah. Okay, that's fine. Async SSR pending. So yes, it looks like Svelte. Yeah, this is how they're going to get a lot of the topic we talked about earlier. They're trying to get async streaming automatically. SSR forking. We preload data, navigation before it even occurs, tap it, import modules, load function around this paper is configurable, of course. Okay. For this is transitions, to best I understand. You make it work. Async group happens. It's like quickly and some forks. It sounds complicated, but really it's not that different now. Async updates. We're already working on this. Right. Client server utilities, server endpoints. Unless you want to create server end for anything you want to fetch inside. Oh, so they're adding use server as well. Interesting. I think someone shared a link to me what this looks like. Query act. This looks very familiar. Okay. Into it. I mean, this is just, I think, the obvious natural evolution of these things. I like it. Okay. There's obviously like more details I'm not seeing here, but type theory notices no start transition, and you saw it, you encountered start transition. Well, the funny thing is you probably haven't. Most people don't realize the router does this automatically. It's going to allow you to update statements this way. So we don't do that. Instead, we. Yeah, that's actually not how transitions work. The function allows you to update state in such a way the nearest suspense doesn't follow. The way transitions start from the top, they basically say when I start this state change, I'm going to essentially, I mean, React is re-render, but in like from the state change, like whatever component runs it, the suspense boundaries above don't matter, and even the suspense boundaries below don't matter that much unless they're new. Existing suspense boundaries participate in the transition all the same. So they basically just like move forward. If they hit a new suspense boundary, they're like, okay, it's fine. That will fall to fallback. But otherwise, what they'll do is they'll like basically fork the reality or fork the reactive graph or fork that and run the other reality off screen until such time all the async is resolved, excluding stuff in new suspense boundaries. But the important thing to understand is transitions are kind of like a global thing. The importance part, and I kind of showed that in my other example, is like if you go into a future URL and you just want to go update the URL to the future URL, you don't want tearing. You don't want like even if the main part of the page is lower, you don't want like the tab where you click to highlight the next page before it's ready. So it actually locks the state from the very, very top and has nothing to do with actual boundaries. The boundary part is only in terms of determining what participates in the transition of newly created stuff. Something doesn't connect to given P state, power, prevent it changes state from being corrected. We think that, okay. Instead of the state changes resulting in asynchronous work, always have their effects deferred until the async work is complete. Well, that work is ongoing, effect pending is true and pending. Okay. Interesting. So they are doing something that's transition-like, but they aren't forking. So it's kind of like a locking approach, if I understand this, because what they're doing is they're essentially saying, okay, you can update the async state, and everything within this region or bounds is going to be not do its side effects until everything is done. So they're kind of doing, and then it's saying you can use it as pending is true. So this is like implicit transitions without forking. Interesting. Okay, let's continue with this. It's possible that something distant can do in place. The particular differentiation is reflected. We think this pro to the alternate which updates us. This is for the in which case updates outside use. Yes, yeah. See, the thing that everyone hates is the random fallback to fallback. See, Solid's 2.0 solution's different than this. That's interesting because we're opting in to tear. Basically, there's only three things you can do. You can stay in the past, you can bail, and you can tear. Those are your three options. Transitions stay in the past. Felt's approach stays in the past. Solid's approach tears by default outside of transitions. That was the difference here. That's interesting because that has implications because that means that their solution is based on bounds. I wonder, you know that demo that was the wrong demo? I wouldn't be surprised if Svelte doesn't work with nested waterfalls. I wonder, because the way they hold the effect, yeah, like I wonder if like I see the parallelizations of the await, but that's like block scoped to the same thing. Like I wonder if nested fetching gets affected. Huh. I don't know. I probably don't have the means to, at this moment to do this, but I think someone who's interested in this should probably see if you can do this example where you can have three components all nested in each other, all fetch data, and see if it doesn't waterfall. I suspect that might not be the case in at least the current proposal implementation. Just kind of things I'm getting from here. The other thing is overlapping updates that touch the same state must be applied in linear order. It's possible to imagine state its A is followed by its B with one. Since you then we show stale values to such change. Yeah, see, they're concerned like React about not showing stale values. So this, yes. Async derives are eager. Yes, this is you get the diamond problem. In fact, do we still have the Excalibur up? Let me see if I can. I didn't actually use this today, but yeah, there's two problems that you hit when you're doing this stuff, right? You have the diamond and the flag, right? And if you have let me see, let's get in here. If you don't fetch eagerly, so you do a state change, and then if you don't fetch eagerly on both of them, there's a potential that you create like I guess that's only a throwing version. Their version doesn't throw, but if they still have to hold execution, right? Because if I'm understanding the Svelte solution, instead of throwing, when they realize that like B is async, they don't run D. but then if they don't run D, they can't discover C. So async has to be eager so that you know to run B and C eagerly. So even without throwing, like they're smart enough to not run. Like basically, because the compiler they can add extra information. Solid's case we don't know, so we just run it and go woo and throw away along the graph. But then you know the difference is effectively becomes a not a huge difference because okay this runs throws immediately. This Svelte version doesn't run, but is aware that this doesn't need to run because it's async. You can't discover the dependency of C. You know what I mean? Like so like yeah, the eager thing makes sense. Okay, let's keep on going. This really is the fact of sourcing in the trench coat. We've had this in effect and promise for the most part. You don't even think about it. Blah 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 blah. Impossible create unknown derived and blah 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 blah. It's not possible. It's effects only executed inside other effects. Yeah, so it needs to be part of the ownership tree. Good point. Context preserved in expressions. Interesting. Yeah, because they're hiding stuff and using a weight, they think about it. Generally, we always assume that after like it's a weight is like bailing out of the synchronous execution, so we're not worried about it. But they're encouraging a weight. Yeah, okay. So no async drive by. So while you can do this, yes, that makes sense. Will then be a promise, not the weight. Why? Okay. Focus inputs are not overridden. Okay, interesting. Yeah, there was a comment. I think there's a lot of really good discussion here. I think the key difference is the default behavior of opting into tearing versus not tearing. I'll talk about that in a minute. Um, where the search changes before the result of the previous one. Yeah, the problem. We'll talk about the yeah. This is yeah. Let me get to yeah. Okay, someone was like, "Solid user never use create resource." Blah blah blah. Very happy with create async. Create sync isn't part of solid, it's part of router, not important. The program model, blah blah blah, nothing create sync. But let's see here. Okay. Currently solid's resource are different. It's the same non-blocking, blah blah blah. I'm basically I think the problems that we're trying to solve with these solutions, and when we're talking about ergonomics around this, is first async isn't completely colorless in the sense that async values can be null in solid, where this solution that's being proposed here, the async values are not null because it's a weight. You know that you'll have the value when you get to it. So making it non-nullable is a big part of the solution. Obviously, Solid 2.0's version does that by throwing, but this is an important characteristics of the solution. The other thing is suspense being too eager to bail out is really easy to trigger suspense with a small async update on the page, causing return to fallback. Using transitions is one way to avoid this, but most of the time people would probably rather just tear. This has led to stuff like use deferred value in React and latest in our resources. This is tearing. When you use deferred value or latest, you are tearing. The truth is 99% of people will never knowingly use transitions. They're mostly there for routing. The cases that Rich referred to in the forking section. So they aren't generally part of the experience of developing. However, aggressive suspense bailout can get people there much earlier than they intend. So yeah, basically, the Svelte solution has solved both of those problems. That like both the problems we have in Solid 1.0, which is the non-nullability, and this one here, which both React and Solid have, where the suspense and even Vue, I guess probably anyone who's done suspense so far has generally been really eager. But the way we're approaching the solution is actually a little bit different, and I'm really interested to see how they manage the flag problem. What I talk about the flag problem is Diamond. We understand the flag problem's a little bit different. It's when A has async that feeds into other async, and the challenge with the flag problem is that this is like a signal that triggers two things. So, like, say a user ID that fetches a user and then fetches user's post, but the user's post fetch requires something from the user record to also fetch it. So you create this kind of flag problem. The problem is if you don't block along the graph in a certain way, you have this challenge where let's say users one, you fetched user one and you fetched your stuff, you're fine. And then you update to user two. This will immediately trigger both of these because they get notified. And then if B is, will fetch user two, but it's possible C will try and, if you don't have like throwing or blocking or something, C will try and fetch using basically user two and user one's like other thing you needed to grab off them first, and then when this finishes, it fetches again. You get like a double fetch based on that. Now, with Solid's throwing approach, this doesn't happen, and I imagine with Svelte analyze approach, it doesn't happen. But it is an interesting thing because these are both very key problems to solve in this space. Because, like, if you try and be too predictive, like too like get ahead of yourself, it's very possible to cause this double fetching problem. One thing, as I said, I really liked about Solid's current our 2.0 solution is we solve both of these problems. The downside of what we've been doing here is that actually, I don't know what the downside is. I guess the fact that async can be hidden, like you don't have to wait everywhere. I think there's interesting implications. I think the tricky part about this solution, I like the compiler part of it with the await. I think the tricky part is the blocking by default is challenging. It's called the type ahead problem. The type ahead problem is when you update state in a search box and each character triggers async for a fetch. And what React suggests to do in this case is use deferred value. So like basically you can show the torn state as you type, and then the async part does it separately. Now, I'm the boundary primitive here might be able to manage it, but I think one of the hardest things about transitions is that people don't realize they're in a transition. If you click a button, it does something. Let's say you wrote the code to work a certain way and there's no async, and then everything's snappy and immediate. And then someone adds async somewhere, and then suddenly stuff stops updating right away. And yes, you can use pending or is pending or transition is pending or whatever to tell you this, but the person who wrote the original code and saying, why is my section slow, has no clue why this is happening. There was actually a JavaScript framework that went pretty far on this. The creator block DOM, I think it was called Odo or Owl, did this did transitions by default. And this was kind of like I looked at it a few years ago, and this was kind of like the challenge here because stuff being correlated that had no business being correlated. Now, using something like boundaries to set like a UI correlation probably is a saving grace here, because then you can say like, I can assume stuff within this zone wants to be updated together. But it's a tricky problem to like. I think we covered this last summer. It's very, very difficult to say by default stuff's not going to update when you do it. People expect tearing to the degree that like you almost have to always just give them tearing as the default. Bailing, as much as I hate it with suspense, is really awkward. The way it wheels up, people sees their stuff responsive. We get issues on the router almost monthly where people are like, I click the next route and it takes forever to load, and it shows the current page and your router's slow. And it's like, well, it's because it's using a transition and you guys aren't using the is pending, essentially. That's an example where we opted into a transition without basically, I mean, we tell you in the docs, but who reads the docs? You know what I mean? Like we basically said like, hey, this stays in the past, and that's how it works. It's interesting when that implicitly can happen literally anywhere. I think my guess, given that Svelte's community and what they're into, I think this might be. I can see communities that would have no problem with this. Like if Elm did this, everyone would be like, yes, it's the best way possible, blah blah. But I feel like a community like Svelte's might find this a little bit like it's the correct thing to do, but it's also like maybe the non-obvious thing to do. There's a tension here. Yeah, that's interesting. When people start blocking, like, no, I mean, there's that part too. I mean, but I mean, you can't win. You either say Yeah, I mean, this again breaks the normal semantics of JavaScript. I think actually Rich we commented on responded to my comment along this lines. Where did he say it? Have you see here with the repost. What's the pronoun in this case? Just the fact that I'm not dealing with promise in a way that feels JavaScript native, but rather via frameworks abstraction. I totally understand why it's the way it is. It's very better taste, but I don't think it would be right design for style. I do like how aggressively created async creators are discourage waterfalls. In the worst case, our design trade-offs a little more performance or ergonomics here, though on the flip side, it means that people are encouraged to learn patterns and to avoid waterfalls that apply to all their code, not just their components. The JavaScript native thing is obviously a minefield. So all this transforming your async code and doing all sorts of things we haven't seen, but React and Solid throwing to trigger suspense feels inequivocally magical. Yeah, it's interesting, right? Because the core idea behind the throwing is trying to add basically algebraic effects, and I say basically, which is hilarious, to the language. And I didn't know what algebraic effects were until I read the very great Dan Abramoff blog about it. But this idea of the ability to use basically try catch to remove coloration of stuff. So you can basically write code in a way that seems sensible, and then if it has problems, where it can't do what it's supposed to do, it asks the parent how to resolve it. And in a sense, like that's what try catch is. So if you come from it from a functional point of view, it makes perfect sense. We don't even throw promises; we throw errors. But it's still the same conceptual thing. Like, don't get me wrong; it is weird to like view a world where you're like, where you go, I'm going to try and do this thing, and if it doesn't work because the value isn't ready yet, that's an error, and we'll try again when the error is resolved. It's in some ways actually, sorry, that makes a lot of sense. But no, like it's kind of like people don't expect that using errors that way to be embedded into their programming model. So yeah, I mean, it's interesting because this definitely has a lot less ceremony around it. As I said, this is a bit largely an ergonomics thing. I, but the decision for like the hold or not to hold or fork or not to fork and all that, I think that those kind of decisions can be made independent of the API. So my gut here is that we'll see how this progresses, and like, but hold by default, I think is confusing. Like it's just very, very confusing. People just don't see it coming. And I'm like, as I said, if it's just the router doing it, then you're like, the router better shout it in the docs. If it's like anyone does like an await somewhere does it, like it's tricky. I don't know. That's my only feedback. I think the design looks great. I think the fact that they're exploring fine grained RSC style like stuff, like all these pieces are like very much needed and welcome and stuff. I think it's pretty sweet. I think the fact that they have solved the exact same problems that I was solving, in terms of, you know, parallelism, colorlessness, removing sense, and came up with something like this is you know really awesome. I think Svelte developers will get like big benefit from using this API. Um, I think even that's true with us too. I think there's still a lot of like devil in the details in terms of refinement here, and we'll kind of see how this plays out. But I do like the idea of like getting rid of used deferred value or like latest, and being while still being colorless, which is, as I said, something that we've done also in the Solid 2.0 design. Basically, um, I think the details that are going to matter to that I'm going to care about, less about the hold forever. I'm really interested if the nested components scenario works, because killing the waterfalls and solving the flag problem at the same time was the point when I finally was like, this is the solution. And I actually have to thank Dominic Ganaway for that, because he was kind of put like I've been, you guys have seen my stream. I like had like dozens of these like articles that we've been talking about, and we talked about this holding, no transitions, yes transitions, hold, block, all the different variations for like months. And then Dominic's like, I think we have a solution with Svelte where we don't do it. And I was like, oh, I went through there, I couldn't get it. And then it coincided with some work that I'd just done with Dev. And then it was like, bang, the idea that you could hold inside the graph, yet tear on the edges, automatically basically solved everything in one go. But I mean, there's always going to be trade-offs. One of the biggest trade-offs on our approach, for example, is it's possible for people to use stuff in event handlers and not trigger suspense. I think this is much more component centric. The way they hold it basically means that it's just not possible to hit some of those kind of scenarios. But I think on the other hand, it means it's not quite as transportable. It's not quite as it's not quite as granular. But I mean, does that matter? Probably not. Anyway, yeah, expect waiting to blocking normal JavaScript. Yeah, sorry, I know I already talked about this, but that was actually the problem when I talked to Theo. I eventually dropped it. I was just like, when someone sees a way to wait, they're gonna it just messes with their brain. I can't do that. That's all ultimately why I didn't. I think what I liked about this approach the most was that it's not a stretch to convert this into generators for SSR because people have already marked the await in their templating. You could literally basically just yield it at these points, and your SSR. I told you how we were simulating generators with signals. You could actually compile to generators with this dirt simple. Basically, the developer is telling you where to put the yields. It's very smart. I don't know if anyone's seen the Dust template language. Template, yes. It's old. LinkedIn created it. It was one of the first streaming templating engines. You're not going to see it. It basically had a very similar way to essentially to block out right in the templating language, and that's what this makes me think of, which is I think really, really powerful. Okay. I don't know if I have anything else to say about this one. I think the defaults in terms of holding are interesting. There's going to be slight differences in this model. So these aren't the same model exactly. So it'll be interesting to see how they play out. I think they both solve the React problems though, just in slightly different ways. So I'm still on team transition though. I think you have to know when you want this behavior. I think it's funny because I'm saying it's going to get hidden in routers anyways, but I think you have to be aware that this is happening. If someone just throws some async on a page, it is very disorienting. Maybe not as disorienting as having your whole page blow up into a fallback, but it's disorienting when you have no freaking clue how async got introduced to your system and breaks it. That was one of my big goals with Solid, is because if any signal can be async, the way we've designed the system, I have to make sure that stuff continues to act predictably for the people who aren't using those features, or who are even in the same project with people using those features aren't using it. Keep parts to the isolation thing. That isn't always completely possible. If someone loads the data that you need to show your component, then yeah, it's going to take a minute to get that data. But or a second to get that data, not a minute. I hope not a minute. But it's not a matter of some, because things just happen to be sitting next to each other. I don't know if I need to go any more on that topic. I covered almost a complete stream on why transitions by default were really, really awkward. Because honestly, I would love to get rid of the need for transitions. It was last summer. I wish I remembered which one that was. Signing transactions. No, I think it was the one when we were talking about consistency first. Towards the end of my I asked if there no suspense. Yeah, it might be worth a reread again, but implicit transactions. Every setter could cause a transaction. How would you determine if it was pending, and how would you show it? The signal, blah blah blah. That's fine. Yeah. Important to understand transactions aren't often out on read. Everything's complete because of the latest. React has this new suspense boundaries, type ahead problem. Implicit transactions would, yeah. If anyone wants to read more on this subject, I did a stream on this too, but I'm gonna just drop this in here. Okay. What else do I got on my list here? Oh yeah. I got one more thing. That's related. I saw this. I thought this was kind of interesting. Dan Abramoff, cells can implement concurrent rendering in the future. because yeah, this forking section is completely what concurrent rendering is. Kind of love that there's barely any hint that this forking is what React started 7 years ago. To the ridicule of the style community. Who needs that? I'm much more excited the bitter the goals upstream needed. Yeah, yeah. I mean, this is. I remember when I came in defense of this, I couldn't believe everyone was lambasting React for creating transitions when, like, yeah, the fight credit and friend words are petty. Everyone's experiencing blah blah blah. You know what you're thinking, blah blah blah. Blah 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 blah. We thought the ability to delay updates pending coordinating is extremely low. We never said we just took a long time to design met our threshold, but it's we don't really talk priorities. That I'm not aware of previous connections to what we have in mind now. It wasn't just you, but I'm just spreading them out is also miscarried to the future. We worked was an ability to compute free tree without committing. That's quite literally the forking section describes, of course. Yeah, because everyone, it's part of this is the React team's fault for showing that stupid radar. That was never the coolest part of that demo. Everyone was like, oh, look how you can do the 3D thing and Paul Henschel and all this. But the coolest part about Dan's demo from was when he was switching between the tabs and it wasn't changing to the new tab till it was ready and it was showing the pending state. Like that is the coolest part of that demo. So funny, it's like not what other people noticed. Yeah, it is the same thing. Yep, his Iceland talk. We talked about single CPO and IO. This is what they call IO bound. Yeah, it's arguably the first mainstream UI forking that shipped. Yeah, they shipped it in Canary first. We released it before React released it. I was so sold on this. I mean, this is not. I'm giving them all credit though. Like I saw their version and then released it to production before they did. Yeah. Anyway, as I said earlier, I think we're going to see more of this. I think this is one of those topics where React got it really right, and I think we're going to see with resumability and quick in like 5 years, people are going to be talking about this similarly. All right, how's everyone doing? You guys still alive out there? I'm almost done with what I wanted to cover today. With my new stream time, I can only stream till about 1. I I I think there's been a lot of interesting stuff developing the last little while, so it's cool to see that. I had one other interaction with Dan on Blue Sky around server components, because people are still kind of arguing about it. Because Dan's been really doing a ton of blog posts over Reacted.io, functional HTML, with use client doing impossible codes. He's basically since here React for 2 computers, he's basically re-implemented server components from a different philosophical standpoint every week and see which one clicks. Where is it? Blue Sky. This one, love your article. I'm not convinced it's the way to move forward. You want 2 worlds separate. People like clear bet. You want to keep the world set the 2 environments differently while context, blah, 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 the connection between them, blah, blah. You actually can statically enforce boundaries. So importing something on the wrong side will refuse compile. Yeah. Something worth noting, there's no need for throttling because your server isn't renderable in JSX. So it's not going to accidentally hit the server while rendering. Yeah. So because there's no weird cascade happening here. Regarding caching, server no longer cross-communication. We're going to test server. I'm just strongly disagree that they solve this. I'm not aware anyway that they would force a single round trip across modular code, which is one of the main things that ensures. No, I mean, you because of the hoisting, you can. Single flight mutations is something that we can do. Take this down. Rewrite this first. Okay, yeah. So they're talking about. I mean, there's two different ways you can solve this. One, yeah, what he's talking about. Let me see if I can get it here. He's talking about, yeah, like data, like having a parent fetch the child, right? And like basically he fetches some data up here for the list and then each host also fetches its own data. I get it. So cascading n+1 problem. And the answer is like, yeah, I mean, there's a couple ways to solve this. One way, if it's hoisted, like route, you can obviously like have all the server functions basically cascade, like build onto the same request. But we're assuming that they aren't discoverable because they're nested. Like you have to fetch the list to get the list. So yeah, how would you know which ones are sure? I think the reason that, right, and then what's the Dan say? I think I'm more. I have an entire list of posts for you, each with some limit. You'd have to make the one request to get the IDs, and then do 30 parallel requests. I think the reason this, yeah. So Dan's like, look, the get the cascade, you have to do the one request, and then you do all the requests. And my response to this was, like, I think the reason this argument never carries is because people have been solving this problem since the beginning. GraphQL is a solve, hoisting is a solve. The only thing people don't intentionally do is make 30 parallel requests. And a trivial example can always avoid it. The solution in all cases involves building up a larger data set in a single request on the server, which becomes more specialized to that specific part of the UI. So you do make server components in a sense, maybe made of JSON, but now you have two locations to update when any code changes. It's not like MVVM versus components. What I mean is like MVVM was basically the component model. View models are basically components, except because the view model tree was separate from the model tree. When you updated like what data you needed for the component in the server, you'd have to go over to the model tree and update it, and then you go over to the view model and update it. So you update it in two places. So in a sense, if you go, okay, I'm going to be getting a list of users, and I know that I need to get all like cascading thing. You're just going to make one server function to get the list of users with the fields you need, and maybe that's configurable as an argument. There's a lot of options of how you can combine this into a single request. But generally speaking, because this location needs these fields and this other location needs these other fields, you are in fact creating a kind of specialized data set. That means that like when you change the fields, you have to update it in two places. I think the composition argument is fair. The part that is less obvious is how easy it is to have multiple trees on the page that can entwine. What if you don't need to update the whole page on every mutation? It's a lot easier to picture that in a decoupled model. And I think this is really where the crux of this discussion has gone to now. Because essentially, we've gotten to a point now where people, I mean, you can see, yeah, you can serialize stuff, server components, sending UI, interchange it all in a single request. That's great. But when you have to go change something, when your app is actually something that updates frequently, more frequently, maybe a dashboard, maybe something, it's very hard to see how you don't just like throw out the whole page every time because it's all part of a single tree. Basically, the same superpowers and strengths that came in here to like allow you to do this single tree also means mutation isn't granular. So a lot of people are looking at like you can use the route level. Actually ends up being a very commonplace. I think next app router, you can, each nested route section can basically act as its own independent tree. You don't have to do the whole page. You could just do it from the route section. And I think what's happening is if you have, it's not about interactivity, but pages that change like dynamicism significantly enough, it's very hard for people to see how the single tree, like basically they're kind of at odds with each other. The thing that makes this solution so great is that it entwines everything so like you don't do multiple requests. But the thing that makes it so terrible is it's hard to break it apart. So this tension is basically, I think, where we've been sitting. Like it leaves people like Tanner trying to figure out how you can add multiple React server component trees to the UI, which then again also defeats the biggest benefit of React server components, which is the ability to, combine the requests into a single zone. But I think that's where the tension is. And then maybe if they find a good balance for it, then like people will be happy with that, and that will be the magic. Uh, anyway, yeah, I don't know. I read an interesting blog post about server components. Similarly, I'll share this one. It was called "Server Components Giving You Optionality." Just to kind of wrap up here, it felt like it was related, even though it wasn't, to like the conversation we're having. The whole idea was that server components basically just give you your code runs on the server client, meaning you. Okay, what does it say? With traditional rendered CSR apps, your code only runs on the client. That's trading off UX or more elementary DX, generally use dashboard style apps. With SSR, your code runs on both, meaning the same code, With the RCs, you can have full access to the prior two paradigms, yet add one more, your code can run on the server only. It doesn't seem like a big distinction, but it actually major ramifications. It does, I agree. So yeah, universal isomorphic, seems to be noticeable. The data, blah blah blah. But ours has to it has to render on the server and the client. What server code must run on the client? What if the same code? On the server. I mean, there's lots of ways to run code on server. Yeah, and then they're talking about RCs without the optionality. Some pages have to render statically thing. Yeah, I think the premise here is like the cell. I think the challenge here are Cs don't come in at zero cost. They require rethinking how we structure app sites, right? Because the structural aspect is actually the whole problem, like concern. Tooling build systems are more fraught. That's fine. That doesn't matter. So is SSR. I believe for now, RCs are a tool for front end professionals. Expert Swiss Army knife that gives us fine tune. The only thing is they don't like they give you fine tune control if you assume that the basis is. There's a few problems I think the React team might consider solving for the RC handoff that might do like if there's a way that you can precede like really easy pattern for preceding the data from the server from the RCs and then like update and mutate it from the client afterwards. I know that breaks the consistency of the model, but I'm wondering if that would help. Um, like even though it lets you choose which environment, the truth is your client code still needs to go to the server. Like you don't eliminate that need with RCs. Like suddenly you have two different data. You have an RC data path and then you have a client data path. So it is very much putting both options. And in a sense, that's an expert level thing where you can have them both things. But the problem is when they become hybrid, everything becomes client components. So it's like there's a mismatch here. I think this is the argument I would have made for RCs a few years ago when I didn't understand them as well as I do now. The fact that you can do both and all put it side to side is incredibly powerful. But the trade off of how they like the devils and the details of how those things wire together, I think this is why it's like there's a lot of people coming to them from a very client side perspective, and it's just pure hurdle, even if technically speaking, incredible capability to do even more. I missed this, and that's the part that I probably should spend more time on. I was reading the description, and I admit that from that alone, it sounded like a lot of the coordination efforts were in a blocking, and that might be the wrong assumption. W- I, I might need to. No, I don't want that. I might need to actually. Is there an example? Yeah, it's because these when I saw these examples, I was like, okay, this is you know, yeah. Yeah, I think I need to make examples, like spend more time on it to actually like and I said this when I was covering it, to actually like see the repercussions of it. Yeah, like there was those I saw those demos. Maybe there's like I've read a lot of the discussions here. It's just there wasn't there's a discussion about is there a type ahead? No, anyway. Yeah, the interesting question with server components generally comes is like, what if those islands make up 80% of your page? How much does that change your perspective on it? Yeah, well, we're gonna server components we spend a lot of time on, which is a kind of a different thing. And this felt async stuff. It was just at the beginning, so I think we'll probably spend more time on this as it fleshes out. If people make um, more examples and demos of like how these things work. Um, The one thing I did want to try, Dom, that I didn't get to try is I didn't see how nested fetching works. Like if you have a component that fetches data and another component inside that fetches data, not based on that, just completely independent data. Like so, not like a cascading reactivity, but like basically two completely independent fetches that are nested because of UI. Yeah, I mean, yeah, I mean, it's like this is the kind of tension, right? You can get all the data in one round trip, but then what if you don't want it all in one round trip? Like there's an interesting architectural tension. Okay, let's see. I'll bite. I've got about 10 minutes tops. Let's see if I can. Let me see if I can understand this because maybe this example will give me a better insight into what we're doing here. Okay, but maybe this is just okay. So we put a boundary around. We have three components, and each component fetches its own data. So this is parallel fetching, and then they all take 2 seconds. So how do I just refresh? Is there console here? Imagine this is just imagine this is oh, okay. I see. Fetching and wrapper fetching. Yeah. I see what you're saying. So let me because wrapper, where is wrapper? So the children are fetched in parallel, these two, but the wrapper. Okay, gotcha. And this delayed has nothing. There's no coordination. Okay, so yeah, yeah. I think it'll be interesting to go into the more details in the future about um, how these things work. Oh yeah, that's yeah. Sorry, Dom. Maybe if you send it on Discord, I can see if I can grab something. The YouTube chat filters out links. I don't know if you have access. Yeah, Discord's probably best if you have it if you're still around. I see. It's gone from effect pending to snippet pending. Okay. Okay, gotcha. Yeah, which I'd have to manufacture this. I'd have to mess with this demo a bit to actually make it do that. We'd have to actually have like a driver that drove. Like it doesn't even. You'd have to drive all of the fetching because to actually see it. Yeah. Oh yeah, you and Jay Larky are going back and forth. I wouldn't worry about it too much. He knows what you're saying. He sometimes likes to push it a little bit. Everything is server first until you plan. Yeah, I think this is a good way to approach, and I think more people should be using Astro honestly, in general, because of like there's a whole category. It's just interesting that React typically catered to the application developer. So now we're kind of in a zone where people like the primary audience is like kind of missing going like how does this work in my thing? It's not just the mental model of it. It's literally like even if you give them the use case, you're just like, what's this supposed to look like? I think it's a great exercise. As a framework developer, it's always fun to go through that exercise. Like people gave me some of the hardest effects to split, and they're like, how do you split this effect? The sad part is sometimes when you go through that exercise and you end up with like better code, the thing is that you realize that the developer would have never got to that solution in the first place. Yeah. Anyway, with my new stream time and stuff, I got to wrap up here. Eventful stream. I think we got through a lot of stuff. So that's good. I might be a little while again. Getting ready to move coming up here, and I've been, as I said, working on a new compiler for the solid SSR. It's so funny because I know writing this that like if we go to like something like resumability, we'd be writing a new compiler again. The key part is that the client and the server match, which means that hydration and server outputs have to go lockstep, and the client only stuff doesn't actually matter as much. It can be like optimized for its use case. So like it is a very interesting how different like the world goes when you start focusing in on those kind of specific optimizations. I'm hoping we just find a happy middle place. I was really hoping I could just skip this topic for now and just get out all the really cool client side stuff we've been working on. But it looks like Solid 2.0 has to be the complete solution. So, like in terms of, I mean, it was always going to be complete, but it has to actually include all of the stuff updated to work in this model, which is fine. It's gonna take a little doing. I mean, I I don't know what that means. I mean, I guess I once accused Misco of not having actual resumability because his components reran because they were VDOM, and then he added signals. My pseudo resumability, like the problem with the resumability of the topic in general is like you still at some point have to convert the serialized data back into a signal graph. Is that different than constructing it while hydrating on the page? Do you know what I mean? Like you don't actually have to, like you still also have to add the event handlers on the, like you still have to actually do the basis of hydration. It's whether you use a component tree closures to do it or you have a routine on the optimal data set. The biggest difference is you don't have to run the computations, right? So like, well, as I said, what's actual resumability? I don't know. Like what if you ran all the components but didn't have to run any of the reactive scopes? Is that actual resumability? I think Quick's definition includes the ability to lazy load code. And I think that's probably more interesting, which is you basically have to turn the graph on its head. So the effects are the top of the graph, not the component tree. And I think that's the key part. Because you want to have that ability to actually execute things lazily. Not necessarily load it, but execute it lazily. Things become signals lazily. A lot of complication there though. So yeah, I don't know. Maybe something like resumability. Dominic got the link. I will give it. I literally got just a couple more minutes left, but let's see what here. All right. Input, bind value city. Okay, sweet. Yeah. So this is the type ahead problem. This is what I was worried about. France. Sorry, no. What am I looking for? We did Paris. Let's do London. Right. Not sure. Am I introducing a different way? There's like a lag that I'm introducing somehow. I don't know if this is the right. Oh, I'm not screen sharing. Huh. Yeah, sorry, screen share. Thank you. Yeah, sorry. So this is the type ahead situation where you have a city. Let me reload this thing, and then you have the search results for the city, right? Paris, toggle. Okay. I think this is the type ahead example. So if I delete it, London. Yeah, there's some kind of delay coming in. I don't know if that's intentional. Let's see if I can drop it in one thing. What's another city that might have, let's toggle full details. Can we do New York? Maybe not that. Let's try London again. Oh, I see. It's what you're trying to. Oh, okay. Okay. I see. So if I, okay, I didn't do it fast enough. I'll get it. I'll get it. I'll get it next time. Okay. Now, if I go to London and I toggle it, Tonga. Cool, and it's felt to like 3 seconds. Okay. Paris. Yeah, I don't know. Maybe I'm just not quite getting the demo. I gotta go now though, so I guess I'll have to pick this up another time. Maybe I'll have you back, Dominic, when we're a little bit closer on release on this stuff, and we can talk about it. Anyway, yeah, I gotta go pick up and do stuff. Yeah, no, for sure. I demoed something earlier today that was like that. I had like an off-screen component, and it was just like it got stuck in loading forever, and I was like, oh, oops. It's all good. Yeah, really exciting stuff that's being worked on right now, like redefining how we look at async in libraries. And to be fair, as I said, React did, in my opinion, kind of start the ball rolling in a lot of this stuff. But when you combine this with signals and fine-grained reactivity, there's just like this superpower that completely changes expectation. You don't have to like block the world. You can do things more granularly. It can flow much more intuitively. So I think this is a brave new world. As I've been saying, the journey into reactivity is still fairly new, and this async area is very, very exciting. So it's very, very cool to see progress here from all over the place kind of coming into the forefront. So Angular recently actually had their resource proposal and stuff, so very, very excited about where this stuff is going. Anyways, that's it for the stream. Hopefully I'll stream again sometime soon. So until next time, let's see, is there anyone to raid? Just only people I'm following are magic streamers. Sorry guys. I will see you guys around.